panel which talks about DoD and mission readiness. So the moderator will be Satish Chikkagoudar, who is a part of our team from the Naval Research Lab. He works in compound extremes and with a, can I say, a sort of focus on cyber and Navy. We have Dr. Craig Poulin. I already talked about him, so I'll not repeat. And Satish can give another, another introduction, and Craig can, of course, introduce himself very well. Lieutenant Colonel of the U.S. Air Force. And then we have Dr. Himangshu Das. You're right there. So Himangshu is probably the only one who is in here. Craig was supposed to come, but there were some emergencies, and of course, we are all resilient in this world. So we have, but we are glad to have all of them here, either physically or virtually. Himangshu is here. Himangshu is from the U.S. Army Corps of Engineers. Very interesting lines of work, including the Texas project. So we'll hear from him. I'll not steal their thunder. Over to you, Satish, for the panel.
Thanks, Auroop. So yeah, introduction to my panel. It's Dr. Craig Poulin. He's actually alumni of Northeastern. So Auroop could have a better. I think he knows better to introduce in that aspect. He's also Lieutenant Colonel at the U.S. Air Force. I think based in Dayton, Ohio. So working with AFIT, as well as I think he has two hats on, teaches as well as does civil engineering stuff. So kind of like mine. So he's coming from a civil engineering side of the house. I come from a more mission side of the house. I have worked in the past with U.S. Air Force, even though I sit in the Navy. So my past life, I was a scientist at PNNL. In that hat, I was supporting the U.S. Air Force in doing mission assurance. Back in the day, we got into resilience from a different angle because we were trying to figure out how to reconstruct and reconstitute things that have kind of fallen apart. The order of reconstitution kind of matters. So that's the angle that I come in from my take on things. We also have Dr. Himangshu Das from Army Corps. We have talked in the past. He works heavily on the flood side of the house. So we have some intersection of ideas. So this panel we are looking at it kind of grounding to the putting our what you call ears to the ground kind of a thing, because the two practitioners coming from two different agencies, and they have their own pain points as to what they consider as the first thing to do when it comes to resilience. So and for achieving mission readiness. So I'll cede my podium to them. So first, I think Dr. Craig Poulin can introduce himself and give his take what the perspectives are from the ground, and to give us a realistic grounding on the thing. Thank you.
Great, thank you for the introduction. So I'll give some general thoughts with where how my background has led me to where I stand with some of these resilience topics. I'm currently in department head for our School for Civil Engineers, and this is the professional continuing education program for civil engineers in the Air Force. So civil engineers being public works, both in garrison locations in CONUS and for the deployed capability as well. And so we do initial skills training for brand new civil engineer officers, military members coming through this school, as well as over 100 professional continuing education courses. And so if someone is in the civil engineer community within the Air Force, whether it's military or civilian, they come through this school at some point in time for some topic. And through that context, very much focused in my current duties on the practical realization of what goes on in those installations and how we prepare leaders and public works members within the civil engineer squadron on how to do their job. And so very much that practical reality of what things look like from the installation is a big part of what we're doing here. I also come at this from an academic background. My time in Northeastern, earning my doctorate, worked with MIT Lincoln Lab on the energy resilience readiness exercises, and focused on infrastructure resilience. So trying to merge those two things has been the focus of where I looked at value to the Air Force. So a couple of things come to mind as we think about mission readiness and some of the translation of what practitioners out in the field really need or could use. And these are all Craig Poulin's opinions, right? So this is not, it's certainly not the Air Force's opinions. It's what I've seen from the position I'm in. I'm a member of the DoD, but these just happen to be a member of the DoD's opinions. And so I think one of the things is, as we think about decision support at the installation level and what individuals at an installation have the ability to do, it's important sometimes as we frame those things of what the decision space is, where you are within the organization. Across the DoD, across even the civil engineer, Air Force civil engineer community, we have hundreds of installations. We have thousands of people involved. And so there's a difference in what you can control locally versus what the system or the enterprise can control. And really what's striking to me is that at the local level, the installation level, there's very little freedom of maneuver. There's not a lot of options you have to advocate for more money. Money is a zero-sum game generally. If you have priorities in front of you, you can prioritize amongst the money you have, but you can't necessarily ask for more. So I think that's one big thing comes to my mind is a lot of times in this space, especially at the local level, it's not about justifying investment. It's about trading investment among other priorities. And so that's one of the things that makes resilience hard is that we have at installations, folks know what's wrong with their base, and they're fighting father time all the time. So the context I have is every day we're fighting father time as a public works mission. We have things failing because they degrade over time. We don't have as much money as we'd like in the Department of Defense for infrastructure maintenance and sustainment. And so we're trying to just make sure the pipes are repaired in time before they fail. We have breaking HVAC units, and it's not based on any sort of disaster. And so that's a challenge. We're also fighting Murphy, who's causing accidents. We have water breaks because of backhoes and vehicles and things like that happen. So those things are what are, for the most part, the immediate focus for those practitioners out in the field in these installations. Then, of course, we have these other less common events we try to plan for and have plans for, whether it's weather events and for the DoD in particular, thinking about adversarial threats. And so the way I approach this and we try to shape our thought process at installations is we need to think about that father time. We're just trying to make sure that the systems don't fail due to life cycle degradation. We also need to prepare for the events that we don't want to happen but might happen, the tornadoes, the hurricanes, those natural events. And then the other part of the DoD that's important is that we think about adversarial threats. And I'm a strong advocate as we think in our hearts and our minds within our students here that there is a difference in how we should approach adversarial threats. And so when I say that, I classify those as the bad guy, right? And there's two general categories. There's non-kinetic adversarial threats, which would be cyber attacks, right? So anywhere, any installation is a threat for cyber actors to come and have non-kinetic actions on your installation. And the other side is kinetic threats. So depending on the location you're at, the reality that someone may, the bad guy, right, an adversarial threat could lob a ballistic missile at your location. That doesn't apply to Little Rock, Arkansas, most likely. We're not talking about those scenarios. But when you look at different theaters where there's military installations, that's relevant as well. And so I bring that up as we shape the way we're trying to understand and prepare installations for these extremes. We have to think about what all those threats and hold them in our mind. The big difference about an adversarial threat is that there is a thinking human being that has agency and will deliberately try to surprise you and will try to get within your decision space, and that should change the way we're looking at that. And that's a challenge. That's a challenge for the Air Force as we start to understand this era of great power competition, as our Secretary of the Air Force will refer to it, and do a better job transitioning from global war on terror to near peer competitor great power competition. And so those three things, those natural life cycle maintenance, which is what's the focus of most engineers on installations, those rare non-adversarial hazards that are less common, and then those adversarial hazards don't always necessarily have the same investment or don't always provide the same recommendation. Specifically, the things we might do for a non-adversarial hazard like a hurricane might be different than the investment we would make if we only look at it from an adversarial lens when we think about cyber threat surfaces and things like that. So just a few examples of where my headspace at, a few other talking points I'd love to get to here. But with that, Satish, I'll cede my time with my long introduction. Thanks.
Thanks, Craig. Any questions from the audience before I just head to a few more questions?
Quick question.
Oh, yes, go ahead.
Greg, since you mentioned the adversarial threats, you guys consider in the context of computational models and all that, anything related to game theory for those situations?
Great. I wish that we don't, I would say we don't leverage that enough in the practical reality of practitioners in the field. I think there are certainly academic models out there. I know Dave has some work in the Naval Postgraduate School and some things, defend, attack, defend. I would say that at the local, at the level of the installation, there's just not the time to think in that process. And I think that's an untapped area where thinking about air bases, whether it's really a wargaming approach, I think you could integrate that to put that into the minds of people's brains of how do we even approach that, right? What are the heuristics we use at the local level to even think that way? There's a cultural change there in the Air Force specifically as we think about these threats that I don't think is there yet, but also it's just the time and attention, right? I think there's an element of a luxury to think about defend, attack, defend, and wargaming type effects. That we don't have if we know that there's 10 buildings on the installation, that the HVAC is held together with duct tape. And that's the reality, the lived reality of many folks at these installations. So I'm going to turn that into a possibility is that as we think about this approach of DoD implementation, the opportunity for the larger system to provide recommendations on how to, heuristics of how to think about these things are valuable. And then also opportunities to operationalize and run local war games and to kind of increase and click that in folks' brain out in the field so they're thinking about it. So I've kind of tangented from your question. Have I addressed the question or sufficiently?
Go ahead, Chuck. Or
Any other questions from the audience?
yes, there were some questions, right?
Yeah.
Go ahead, Chuck.
Jack Watson, PhD student at Northeastern. Speak up. Yeah, so I'm curious about the kind of uncertainties that are involved in day-to-day operations. Like, I mean, we know what the threat space for extremes looks like. It's often difficult to characterize and predict. I'm curious what that looks like for normal wear and tear that you're describing. Like, do you still get surprises on the day-to-day? Like, are you, like for the HVAC systems, you have some expected, rate of breakdown, I'm assuming. And like when you talk about stuff like, backhoes breaking water mains, are those things that emerge or are these kind of things that you have well constrained within the threat space?
Great question. The Air Force in particular has been on a journey for about a decade to better use sustainment management systems and to better understand what assets we have in their condition using predictive models like life cycle, degradation curves, and items like that. Unfortunately, I think the general result of about a decade or 15 years of effort of data collection has been we simply don't have a high enough sustainment rate of the resources we have to really use that data in a practical way. So plant replacement value, a percent of plant replacement value is a general standard used for what the level of investment is in infrastructure and real property. And the target for years has been 2%. For us to be at baseline, we can do something at 2%, even though industry standard be up in the order of 2.8%. And we failed to receive that within DoD budgets, Air Force budgets for the entire period. And so we're operating below 2%. The general impression, the general result is we are doing worst first. We're not doing deliberate asset management. And as a result, the data collection, the juice doesn't become worth the squeeze. And so we're kind of in this trap where we don't have enough resources to invest for life cycle reasons, invest in the right things that we'd like to. And so we just have to fight the fire that's really immediately there. That coupled with resource challenges and workforce challenges of having enough folks to work on these things, the surprises that we emerge are generally unknown interdependencies in that case. So, hey, generally at the tactical level on the installation, if a roof fails, no one's surprised by that. Yeah, I'm sorry, I'll belabor the point. All right, you cut me off there.
Thank you.
Okay, I think that was not meant to be an interruption. It was just somebody joining. But anyway, thanks, Craig.
Oh.
If you want to elaborate, please do. But let us also hear from Julie. I think you raised your hand.
Yeah.
Yeah, thank you, Poulin. I had a question about, you said the installation funding is typically pretty static once you get the funds. And I wondered how you divvy it up between those life cycle maintenance and then the adversarial impacts, whether they're natural or whether intended adversarial impacts. Do you have any kind of rule of thumb on how you divvy up those funds for those types of activity?
And Julie
great.
is just as an introduction, Army Corps.
I'm with the
Right.
Army.
Yeah. And so it changes year to year with business rules and how much is centralized versus decentralized. We've seen the pendulum swing to more decentralized execution for facility sustainment funds, where there's more autonomy at the local level to make decisions between this or that. And I think that's related to my previous comment about we just don't have enough money to make good enterprise asset management decisions. And so what that gives is a lot more autonomy to that mission owner and the relationship with that installation function, the installation engineer function. But they're prioritizing between a lot of different things, from quality of life initiatives to HVAC units that are at the life cycle of failure. It can be really hard to understand and then articulate why investing in something for the what if is worth it. And so where we can use exercises and real life examples to better inform that and to really drive home that emotional, like visceral, oh, if the power goes out, we lose this critical comm node. You need that story in many cases to convince the mission owners to not spend the money there, but to spend it on something else, right? That's really the decision space is you're always not investing in something when you do invest in something towards resilience.
Subhra, please.
Lieutenant Colonel, thank you. It's a Subhra, Misra, I'm with OSD.
Yeah.
Just a couple of comments. And so the integrated installation resilience plan, that's in stage 4B now, so it will be policy soon. And we're working with the Milcon folks to write more stuff into policy that will enable you to go beyond FSM and, use Milcon stuff to be prepared, like just invest in resilience. So hopefully those funds are coming soon.
Great to hear. Right. And I think, trying to separate, I think that is a good way for the rest of the group too, that there's the policy in the high level and there's also that on the ground level, what their lived experience is. And so that's great to hear. I'm happy to hear that as well. Where that relief will come so we can better prioritize and shape where we're spending our money.
Rick, thank you so much for your insights. I was just wondering, I think more on the resource allocation problem, and I think you mentioned about the usability for some game theoretic type techniques. So to me, it seems like there is kind of strategic planning aspects and then tactical planning aspects, right? And maybe there's no one sort of method that fits all needs. So just curious, any thoughts on your end from that sort of separation in terms of strategic, longer term, or more planning oriented versus tactical, which is more near term, and from a resilience standpoint, then how do we be resilient both from a long term strategic standpoint, also sort of tactical near term standpoint, and what maybe unique considerations we might have to account for?
So it's a great question. I think at that tactical level, there's an opportunity to better understand system behavior under extremes. And so there's what do you do with that information? Certainly with the right analysis, it can inform long-term planning and investment. But to the question's point of what does that mean locally and maybe on a shorter time horizon, there's also just understanding what your system's behavior would look like. And we don't have the luxury to run large-scale exercises as often as perhaps we'd like. And so there can be a bad mental model of folks in the field of what things will actually look like and what's important in those times of extreme threats, as well as extreme missions. And so I think anything that helps us better understand that or go into those experiences with a better idea of what priorities might be is useful. And so I'll give you two examples. One is when Hurricane Michael came for Tyndall Air Force Base years ago. Great example, the Air Force thinks in terms of our aircraft and our airfields as being the #1 priority. And that's often the case, although there can be comm nodes and other mission partners that are more important. But the reality is when the hurricane started bearing down on Tyndall, they did what every Air Force base would do in that situation is they moved the aircraft. And so what that does in practice is we think about these extreme events, oftentimes we will have dynamic priorities. I think of it as dynamic priorities because we'll take actions to reduce our threat surface. And so suddenly when we move aircraft from Tyndall Air Force Base, and that airfield is still important, but now the number one priority for that battle rhythm of that 20 to 72 hour period has shifted. And so the ability to understand what those priorities would be in those emergent requirements, emergency situations might be, is important to have in our heads and our hearts and our minds, as I say it, at the practitioner level. The other thing to keep in mind with the adversarial hazards is, I think there is a change in priorities might also correlate with a change in the extremes. So if we have an adversarial attack, right, cyber attack or a kinetic attack, and that's a nation state activity that's like, hey, when the balloon goes up, as we call it, we could also expect that's going to be at the same time where we're trying to change our mission behavior. And so if we want to move a whole bunch of airmen on an aircraft from Travis Air Force Base into the Pacific because of global tensions, and that's when an adversarial attack would happen, we would expect it both changes the mission profile for that Wednesday afternoon and also changes the impact to the system. And I think that's a part where we don't generally, through our day-to-day activities, have a good gut feel for what that might be. And we can only understand that better by investigating our system, by probing it in a way and establishing tactics, techniques, and procedures and a battle rhythm for it. And so I mentioned I started this long comment off by saying we don't have enough time and the ability to do large exercises. The Air Force wants to do more of them, but they're expensive and take time. And so any simulation or tool that helps develop those insights or that can help run a tabletop event as opposed to an actual humans moving around and equipment moving around exercise is helpful to understand what mission requirements and stresses in the system might be in these emergent situations.
Hey, Craig, it's Dave Alderson. Can you just say a little more about that Tyndall story? So you set it up and then they moved the aircraft, or at least the ones they could move.
Yes.
And then you kind of gave a sense, well, now the mission has changed a little bit. Can you say just a little bit more about how that played out and maybe how that resulted in surprise or other kinds of things?
Yeah, absolutely. Great. I wish I was there. Yeah, to have this conversation. Yeah. So I think that's an extreme example. But I think I really want to highlight that when we talk about life cycle infrastructure maintenance and our mission dependency index, the airfield is going to peg that out, the air traffic control tower. Now, when Hurricane Michael comes through, it destroyed, over 80% of the installation was condemned or facility is impacted. And so really in that, where we have a ride out crew, where we had some folks that were there to ride out the hurricane, the goal is then to do damage assessment and then to bring in, have those folks survive and then bring in recovery teams to then get the installation back up and running. Now, in doing so, a priority for many reasons was to get the airfield up and running, as well as other key mission partners. I was not at Tyndall at the time, but through our back briefs and things like that, it changes that dynamic a little bit. And so the key part there is that understand, hey, right after it, the airfield isn't the mission priority. It might be survival of the members there to then reestablish infrastructure capacity for follow-on forces, which came over ground from Hurlburt Airfield, or Hurlburt Field over the transportation network to come and then recover that installation. So it's not that the airfield isn't important, it's just that the emergent requirements could shift. And a different scenario, maybe a smaller storm, if the aircraft didn't flush, then that would have remained the top priority.
Yeah, strikes me that you have touched upon a topic on which at the moment there's almost no research. And that is, for instance, you have said that to have redundancy, right, to plan for redundancy, it often takes a narrative, right? If this breaks, then something would happen. And you said that people have a low understanding of how the system works, so that you would have more exercises and so on. But again, what people take away from that are narratives, right? So how people make decisions in the field and how we can justify it and so on, all comes down to the formation of some narratives. When I worked on supply chain, one critical thing that we were asked to do as mathematicians and network scientists was to deliver narratives that these supply managers could use to justify investment in redundancy and so on. do you see yourself looking at these topics, how these narratives are formed, how to strategically form narratives that can be transmitted to give people a better systems understanding, or to how to construct narratives to basically support a certain redundancy or resilience of the system?
Yeah, I think you hit on something there. The narratives are important. And the narratives are important to set a baseline expectation of where our red flags should be. What should make us uncomfortable or comfortable? And an example would be as we do energy resilience readiness exercises, pull the plug exercises mandated by DoDI and public law. Let's cut the power and let's see how the installation responds. And mission partners and mission owners on installation have lots of ways to approach it. But in some cases, and I would say maybe not most, but in many cases, it's very common for there to be, there's advance notice, we're going to do a power outage exercise. And you'll have someone, for example, rent a backup generator to plug into a critical system so that they can continue operations through this planned exercise. And it will often be, for some folks who are out in the field, these are not infrastructure people, these aren't public works folks, these are often closer to the mission owner side. They will think, oh, I just need to get through this this energy resilience exercise, and then we'll go back to normal. And so what's happened in that case is they've identified this vulnerability in their system and they've taken steps to resolve it, but they don't think of, it doesn't create this red flag that, hey, if the big day happens, if the balloon goes up, if we go to war and there's non-kinetic attacks and it affects its installation, we can expect there to be a regional power outage. Or it isn't in their thought process, and they're focused on surviving the day-to-day sustainment mission. And so I think there is an element where as we look at these extreme events and we treat as much as possible of this is a likely scenario, or this is the expected scenario, how will you survive and execute and operate within that scenario, can produce a narrative that has effects that we may not even see at the system planning perspective. It's going to be how individuals who have a day-to-day job kind of view the problem space. And so I think there's a huge opportunity in using models and the narratives they generate, these synthetic experiences in some cases, to create an anecdote that locks into people's brain and makes them maybe change some of their day-to-day behavior.
I had a quick question. So as you know, as a university, our prime directive for all the Trekkies here is, of course, education and mentoring.
Yes.
So in that sense, I mean, you have done a PhD here, you're doing very well. So for all the PhD students, postdocs here, and as you know, we all go through various ups and downs during PhD cycles.
Yes.
Any words of advice, or what you do what you did for research, even if that may or may not have directly contributed to what you do, how that helps or how it doesn't help. Any other word of advice for the PhD students and postdoctoral researchers from your perspective, Craig?
Yeah, absolutely. And so I'm in a position where I did not continue academia. I'm related. I'm in the Air Force system, and so I did a tour after this, an Air Force assignment after my PhD before coming here, and loosely using my PhD in this position. But what I found most valuable from is kind of the way of thinking. And so where I took the initial focus on the research I generated and trying to have research be as productive as possible in the field that I'm studying. And I focus on that one topic. And then I'm not referencing the work I did on a daily basis, but I think instead what it is kind of the thought processes, right? The ability to approach some of these things, systems thinking in many ways, and feeling comfortable quickly reading a PDF and developing a mental model, and then being a critical reader in some ways. And so that has made me helpful even in a non-academic role where I'm able to think about, in this case, force development and mentorship of civil engineers out in the field, and maybe where the gaps are. And so that has made me a more effective communicator as well. And so I guess my advice would be, do the best contribution to what you're working on right now, but recognize that a big part of PhD is also that you are being developed as a thinker in an area as well, and that's one of the outcomes. That's me also putting on my instructor hat here.
Any other questions? Dave, yes.
Hey, Craig, it's Dave again. We're going to have a lot to talk about, but I want to just emphasize actually for the group something that you said. You said that, from time to time, the phrase you use is there's a bad mental model of what's out there in the field.
Yeah.
And what I would say is that that's not the exception, that's the rule. Like, our models are stale and they will always be stale. We will never know exactly what's out there. And so we have to sort of think about that as we're developing techniques. It's something I'll try to hit more, but we see this over and over again on installations where a lot of the surprise is in part, it can be the events, but it's actually our own systems. We don't understand them as well as we think that we do. We don't have the schematics. We don't have the, I mean, a lot of the knowledge is tacit in our workforce, which is aging and retiring. And that is a huge challenge that we kind of face generally across the board. Over.
Yeah. Awesome. Yeah, strong concur there. And I'll just, for those that are not on the DoD side there are structural reasons why that's the case. When you think about, I'm using an example of, hey, you know, Craig's is an Air Force engineer. Well, if you go to an Air Force installation, you have many mission partners, and they all have different chains of command and different organizations. They don't communicate as well, and it is not run as a dictatorship on an installation. There's many people that don't talk as much as they could, and generally if you go to an Air Force base, the most important mission in there may not belong to the person that is the installation commander. It's going to be a mission partner that has their own mission over here that's more important on the DoD or the national level, and they're different organizations. They may have the common coupling point is the Chief of Staff of the Air Force, the Secretary of the Air Force, or the Secretary of Defense, right? There is such a huge backlog, and that makes communication, decision-making, and resource management really hard. And the other part of that is public law, which we live within, right? And the ability we have $10. What do we spend $10 on? Well, we don't actually have full ability to make that decision. So it's not complaining about it. It's more just saying this is the reality we live in, where if we were to system design our way out of that, it is every day I'm surprised by how challenging some of those things are. And so we got to approach this in a way that uses the existing frameworks. All right. Satish has got something, I think.
I cannot hear you. You're mute.
You're on mute, Satish.
Still on mute.
Thanks. Yeah, I'm talking to the mic, sorry. Yeah, so one more interesting point with Craig, which we were discussing, was I think he was saying that everything is built for optimized for efficiency, right? So yeah, efficiency versus being effective, that whole narrative, I think is lost. I think that's what I think on some of the crux of some of the discussions we had with Craig. I think he can add something more to that equation, I think.
Right. So
Go ahead.
Yeah,
you have that whole spiel about being effective versus efficient, right? So the effectiveness of the thing is kind of lost because you're kind of geared towards being kind of efficient.
Right.
So yeah, it's just kind of everything is optimized out of the equation in some ways. So things are kind of lost in the organizational memory as people rotate in, rotate out, as things cycle out in a regular fashion. So when a thing hits, things from the past were the things that last in some ways. And they're usually sitting somewhere in some closet, right? Lessons learned. Yeah, that was one of the things that we were discussing earlier. If you have anything to add to that, yeah.
Absolutely. So I think what's hard, so the Secretary of the Air Force has challenged the Department of the Air Force to re-optimize for great power competition. So that's a context that I live in is the former Chief of Staff, now the Chairman, Joint Chiefs of Staff, General Brown, has said accelerate, change, or lose. And so we are not where we need to be. And this is a common a framing in the Department of the Air Force right now is we have optimized to be efficient. We need to now optimize to be effective, which is great. And I agree. It's effective at what, right? And again, we get to this ultimately a zero-sum game of resources for the most part. Certainly within the Department of the Air Force, for us, it looks zero-sum because that's between the department and Congress. But the effective versus efficient, if we want to be more effective in certain areas, it means we need to underinvest in other ones. And unfortunately, in the civil engineer side, it means we will take risk in infrastructure because when the Secretary of the Air Force talks about effectiveness, it's often on the mission capability side. So we need more munitions, we need better jets, we need all those sorts of things where we end up underinvesting in other areas. And so that's a reality from that sustainment and where we spend our money. I think fortunately with that in this topic of infrastructure resilience, we can adopt that same idea of how do we prepare ourselves to be more effective and I would say, comma, when it matters most. And that's a part that culturally we're not there yet. In our Department of Defense, our installations, I'll talk about overseas installations within theaters where there might be kinetic threats. I would make the assertion, Craig Poulin's assertion, that we need to design those installations to be prepared to go to war from that installation. Air Force installations are power projection platforms. We launch and recover aircraft from these installations. And so if we want to be a credible capability at the world stage, we need to have credibility that we will have that capability when the bad thing happens. And so you extend that to the CONUS installations, and you look at non-kinetic threats and things like space surveillance. And so how are we effective within those areas? And that's where that is in direct tension with some efficiencies for life cycle maintenance and life cycle day-to-day operations. And even, I would argue, some of the environmental, the natural disaster type events where the ability to ride through a hurricane, those investment decisions may not match with the ability to minimize vulnerability to a cyber threat. So I'm not saying these are in different directions, but they're investment vectors in different decisions. And we see this in practice where there's local, again, if the mental models we have at the installation level, or even at anyone in the DoD's level, if it's not right, they can overlook this. And so an example would be there are installations where we've invested in microgrids to provide better resilience and redundancy and reliability at that installation. I have anecdotal experience where because a microgrid was installed in installation, customers said, hey, we are now, if the power goes out locally, we have this microgrid that'll keep us going. And so they divested in mobile diesel generators because they didn't need them anymore. And so from a mission-oriented adversarial threat thing, that set off alarm bells in my head. I'm not saying it was the wrong decision, but what they said is that, hey, we now have this larger system that we don't necessarily have the ability to control, and we now can underinvest in this really, what is ultimately like a really agenic, like there's a lot of agency in a diesel generator because you can move it and because an 18-year-old can troubleshoot it. And so because of now there's this microgrid that now provided an installation level reliability and resilience, absolutely. What that an 18-year-old can't troubleshoot that microgrid, right? And so we've kind of traded something in that space. And I use that example because it motivates me as I think about this is it wasn't that the microgrid was wrong. It wasn't that it was designed poorly. It's that the interpretation of that at that individual actor level, they didn't link that to going to war at that installation. They linked it to the once a year power outage due to brownouts in California, right? So that'd be the example. So I think for us, effective versus efficient is effective to what when, because to be more effective and less efficient, we have to decide what we're not going to do.
Satish,
Thank you for the chance to pull up that soapbox.
Thanks, Rick.
Satish, can you hear us?
Oh yeah, I think we'll move to Himangshu and then we'll come back to questions. I think we're at that time. I think a lot of interesting discussions with Craig. There's a lot more to discuss for sure.
Second for the transition.
There's also more stuff on the expeditionary warfare stuff, which me and Craig talked about. So that's for another day. So Auroop, are you going to introduce Himangshu? Or I think.
Sure. So Himangshu is, as you can see, the Chief of Coastal Engineering at U.S. Army Corps Western. He has been with us through this project from the beginning. And
For many years.
right, and he has been guided. No, I'm saying yes. Coastal engineering for many years. I'm saying for nice from the very beginning, and he has been guiding us with his experience and with his work in many different ways. So look forward to hearing from you on.
Right. Thank you, everybody. So, as you know, that Craig gave a very energetic talk. I'll be kind of changing the gear a little bit. I'll be talking mainly about the flooding, coastal flooding, in a very basic level. So today I heard from Marta about, the fuel tank problems, inundations. You also talked about, the I-10, I-95, raising. So my work is mainly to provide some data, generate some data, into the inundation data, and so that, all the smart people can use it for information gathering. Right? So I'll be talking mainly about the two projects. One is two different geographic regions and how we basically generate the inundation maps. I think. So the first one is the coastal Texas. Those who worked into the Texas and know about the Texas, you know that everything is big. So the study area is extremely geographically very large, covering more than 1,000 miles of coastlines. The economic values of this region is also enormous. You look at the Johnson Space Center is over there, and also the Houston Port is also one of the economic artery there, and of course the nice beaches, not like Florida standard, but a lot of regions to study this area, understand the resilience and vulnerability of this region. So apart from the economic importance, this particular region is also extremely vulnerable from the coastal storms. So if you look at the historical data, major hurricanes there, and everybody, it's not a question about when the next one will be coming, but it's a question about how we can prepare ourselves so that we can minimize the damage, right? So that's the objective. The study area also is extremely vulnerable for many different threats. Throughout this today, we talked about the compound threats, but here, if you're looking into this one, we have pretty much everything from the natural disaster standpoint of view. Of course, the hurricane is there, and then the rainfall. If you look at this Hurricane Harvey that's happened in 2018, it jumps like more than 60 inches of rainfall over there, and the sea level rise. But is also Galveston, Texas is sitting into the hotspot of sea level rise changes. So if you look into the curves over here, if you believe it or not, but anything from 2 to 5 feet for the next 100 years is a possibility there. And of course, the land loss there. And if you look at the sea level rise conditions, we believe this one. And from the today's climate to the future climates, the storm surge can be extremely catastrophic there. So there are a lot of regions to study this area and understand the vulnerability of this. So what we recommended to withstand some of the vulnerability here is a multi-line defense mechanisms over here. So it's a cartoon pictures over there. So on the bottom part is we call the from the seaside defense there to protect the surge coming to the inside the bay. Right, so you're looking at the Galveston Inlet over here, roughly about 2 miles long inlets, and of course inside the bay, also about 600 miles square water body there. So even though if you protect the surge from the outside, you still have a lot of big fetch over there, so the wave can generate internally. So you have to protect from the behind also. So that's why I call the multi-line defense mechanisms that we propose. So I'm going to walk you through about what we are proposing in this case. So you're looking into the Galveston Inlet, where the ship channel is there. So along it's roughly about 2 miles long. So on your left side is the Galveston part. On the other side is called the Bolivar Islands. So we're trying to put a lot of concrete structures over here to protect the storms that's coming inside the bay. So here we are proposing about large sector gates. So we are thinking about like a door, right, that is coming like this. So to navigate, have the navigation structures over there so the vessel can go in and out. So we are putting about 650 feet wide sector gates, and then we're also proposing other structures over here. So on the left side and the right side, we're also thinking about called the vertical lift gates. So it's basically it's a kind of you can think about like a lift gate that can drop the structures underneath the ground so that it can block the the passage of the water body going back and forth. And so it's kind of rendering. You can see how the sector gate will look like. So it's kind of one-way traffic. The vessel can go in and out through these gates, and in the event, you can actually close those gates to protect the surge coming the inside. And of course, on the other side, we are thinking about the lift gate. So you can think about it during the opening situation, it's going to be above the water, but in an event, you can close the doors. And also on the other side, we are also putting a lot of the other structures. You can think of the walls type of structure. So there are a lot of concretes into the channel, right? And also on the other side, as I mentioned about, because of the back bay flooding, or the other side, we're also proposing a lot of the structures like the flood wall, floodgates, this kind of structures, and also gates over here. So these are some of the rendering. So you can think about like over here, you still have the road structures over there but in the event you can actually close those gates. So how do we do this? How we propose those kind of things? So to understand the what is the threat there, right? I mean, so the future conditions. So we ran simulations, a lot of the storm probability, like on the left side is all synthetic storms, all the different categories there, from these historical representations of the storms. And you are looking into of course, the sea level rise conditions, because you are not simulating only for the present conditions, you're also simulating for the future conditions, like, if the sea level is higher, what kind of wave it can be, what kind of storm it can be, right? So also different conditions. So lots of simulations we did to understand the design conditions over here. And then we need to see if you come up with a design, what is the benefits, right? So for example, in your case of looking on the other side, if you do nothing, you're looking around anything between 15 to 18 feet of storm surge, right? But with the condition that I just mentioned about the gated structures, you are cutting down the surge probably about 1/3 of this thing. So there are a lot of benefits that we're capturing by installing those gates over here. So you are not only looking into the benefit from the the reduction of the surge, but you also look into if you are hampering the environment. So for example, you need to look into water quality, look into the freshwater retentions over there, because you are putting a lot of concretes into the inlet channel. So you have to look into all the environmental stresses over there. So before you propose any changes. So the next one I'm talking about, this is the island of Guam, right? So this is another study that we did a long time ago, about 10 years ago. So again, Guam is basically one of the islands in the Mariana Archipelago. So it's a very small island. It's not like Texas, right? It's only 30 miles long, and the width is about 4 to 12 miles, and the population is about only 200,000. Again, it's interest from the study area because of the there is a naval base over here, so we need to protect that. And the other thing is, of course, the stakeholders there to protect them too. And if we look into the data historically from 1947, there are lots of, they call it typhoons in the Pacific. We call it hurricanes over here. They call it typhoons, the same thing. But approximately 30 typhoons that was, kind of impacting the Upper Harbor. Upper Harbor is one of the places that the naval base is there. So it was a DoD funded project. So we wanted to understand the vulnerability over here. So we did some, again, similar type of modeling that we did. We created a very large domain, roughly about 660 kilometers, wide, domain over there. As those who work into the storm surge field, that you need a larger domain to capture all the long waves and everything. And it's a structured grid, so it's basically in the open ocean, the grid size is about 14 kilometers. But as you come to the coastlines, you need to resolve it very finely. So it's roughly about 25 meters. So it's an extremely stressed grid over there. And before you come into an operational mode, you need to basically have some fidelity into the modeling. So you do a lot of calibration validations over here. So here you are looking into the validations of the astronomical tides. So it's on the right plot, you are looking into the observed data and also the model data kind of, in the 45-degree lines, meaning that is a lot of, calibration is, well done over here. Not only the tide, we also had to do the validation for historical storms. Not many storms that passing actually the Guam, but it was kind of, stressing further one, but we have few storms that to validate it. So this is one of the examples how we validate the storm surge. But Guam is such an island. It is, if you look at the coastline, it's very rugged. And this, the coastline is pretty steep over there. So not many inundations you can see. So even with a strong, typhoon, you can see the inundations only on the few places there. But the other side is kind of protected because of the rugged, shorelines. So what's next? I mean, so after you do the calibration validations, you need to see some sort of information that you can pass to the decision makers. So we come up with what is the probability of the storms hitting this island? So we come up with synthetic storms there. So here is an interesting plot. So there are 3 different tracks over here. One is right over here. So as you know, if you are in the left side of the storms, you can generate a lot of the surge over here. So that's the plot is showing. So for example, if you're on the right side, the storm surge could be less compared to the left side. And then it's again some information that we pass to the decision maker. So this showing the what is the probability of the typhoon intensity. That means Cat 1, Cat 2, Cat 3, and also if you are distant from a particular point over there. So for example, if the intensity is high and if you're close to the island, so you are on the bottom side, so you can expect more inundations or more, the damage over there, as opposed to the intensity if it's less. Kind of, this is what we know, but this kind of plot, is helpful. If the storm hits beforehand, what kind of intensity or what kind of water level you can get in a particular area. So I hope this kind of presentation is helpful and kind of see what kind of data we generate for you all to kind of do your decision making or optimization things.
So
Any question?
this is fantastic. And the first claim to your data will be by your Buet Junior. I'm just kidding. Who is a PhD student here, but no, we'd love to have this. Work with these data sets. But any questions? Yeah, Subhra.
Oh, just one comment. Thanks, HD. So we're actually with FEMA, OSD, we're co-funding an update of this, which is going to be executed by the ERDEC and the Army Corps Engineers Research Lab. That'll be completed FY24 at the end of 24. So it's the full probabilistic coastal hazard mapping for the entire island. The other thing I wanted to mention, there's an extraordinary amount of recovery, reconstruction, and investment going on in Guam by DoD right now. And a lot of it is classified because of sensitive sites and equipment and infrastructure that we're putting in. But I would encourage you all to maybe consider Guam as one of your case studies when you get to that point. I mean, Guam was devastated because of Mawar. And there were a lot of issues with critical lifelines and supply chains within Guam. We had a lot of trouble getting stuff into Guam. We're still having challenges. I'm on these weekly calls and updates on, how reconstruction recovery. So this might be a good case study in terms of networks and supply chains and how physical natural hazards and the constraints as an island exacerbate, significantly those challenges.
This is fascinating and also just personally fascinating to me. When I was at Oak Ridge Lab, we got tasked by some, I think it may have been the OSD, but some part of the DoD to work on Guam and talk about, this was many years back now, about, what does sea level rise mean and also water resources within Guam as, people grow. So fascinating. We'd love to have discussions with you, some data, and Puya will be after you.
Yeah. We love to share the data.
Oh, see, I told you.
Yeah, so recently we shared with Jamie, with your colleagues to
Yes.
on some data there.
Yes.
So we are data, house. So
I actually see a lot of connection between Leonardo and, Himangshu in terms of, so there's Guam here. Subhra was talking about various lifeline and other systems within Guam. So a lot of connections. So I'll get some of them to pester you a little bit. Please entertain them, the students and postdocs. Who else?
Yeah.
Question, Professor. Oh, please.
I'm just quite curious because your models, your simulation model seems really good. What kind of model is behind it? And the other question is, what are the things that are not well done yet that you may want to see? I'm an AI person, so I'm curious, like, what are the things that we can help?
So, this one and the previous one that I showed, it's a combinations of the 3D hydrodynamic and the wave model. So this one was done with AdCirc, Advanced Circulation Model, plus the SWAN. SWAN is the wave component there and the circulation model tied together. So basically you run the 2D circulation model first and then feed the wave component there and do an iteration process. The previous one was done with another Army Corps of Engineers, as Julie knows about this. It's called the ST wave. So the AdCirc plus the ST wave component over there. So if you look at the USAID's website there, there's a program called the C-Storm. This is the suite of the model that is, web-based. You can use basically that a lot of data is actually over there. You can pull it. But so these are run in HPC or supercomputer because you cannot run it. See, it's quite computationally it was in.
So to sort of Himangshu to sort of elaborate on her question, and we face this issue in, for example, hydrology in climate kind of models. So if you think of one side, the output of this model, if you're thinking of post-processing, so obviously you look at residuals may not have structure, great. If it has structure, you'd like to know more. Could data sciences, machine learning help? That's one thing. Second thing is in the parameterization of these models themselves, if you have some ancillary data, could data mining machine learning help in those parameterizations?
Excellent. Yeah, I mean, I also did some work on the data mining things. So use some forecasting, right? You can use the neural network or some other things there. I see a lot of prospect in terms of the forecasting part over there, because if you want to run a real-time forecasting using a very high resolution grid, even with thousands of processors, you still need about 3 hours processing, right? And then if you look into the NHC side, for example, the forecast is coming every 3 to 6 hours. So you need to have an answer pretty quickly because your decision makers cannot wait for 3 to 4 hours before you turn the answer to them. So you need really quick minutes. So that's why I think the AI and some other things has a real possibility there. Because I mean, you can run offline thousands of simulation. I mean, in a real world, hurricane could be one of these, right? That you already simulated. It could be slightly, I mean, all human beings are different in colors and everything, right? But all hurricanes are also different typhoons. You see that? Nothing is similar. But you can probably mimic one of this one, right? So I think that's what the AI can I see a lot of actually my colleagues are working on this field. So I think this is real. Building this whole database, all the data engines there, and then pick the data mining right over there, okay? Then give the answer right away. It's a real possibility. Yes,
actually follow up on Jennifer's because Jennifer and I worked together on building surrogate regressors for physics simulations. These are, I'm guessing, Monte Carlo simulations. So we actually do that. We build regressors which are simply to speed up expensive physics computations. And since you already have the data, if you have a broad range of scenarios, that is relatively not so complicated to do. It's challenging, but it's not so complicated.
Julie, I mean, we are doing this surrogate modeling anyway, so she can speak for these things.
Yes. Within the coastal hazard system, which is using these C-storm models, we have the machine learning to, if you have any hurricane approaching a coastline and you already have all these thousands and thousands of storms calculated with different sea levels, you can pick a track and look at the impacts of that track. And then it's just like that, right? So when the storm does change track, you can update it really quickly. And we use that in the core just to cite emergency services and things like that for the core civil operations, but it could be any
It's going to be very interesting for us, but we'll come back. You have yes, we'll talk more. But thank you very much, both of you, for bringing that up. Subhra, but one last question, please. 2 minutes. That's what Robin has told me.
Yes, please. If you'll just allow me, I wanted to show everyone, because we were talking about Guam.
Guam is fascinating to me because of various reasons, but yes, please.
He's coming.
It's all unclassified, so it'll be fine. If I can get it. This one. Sorry. Here we go. Thank you all. So this is a climate dashboard tool that was created for us also by the Army Corps of Engineers. This is for all of Guam. We've got all kinds of hazards here for present day and future conditions. So we've got, for example, all the blue stuff you're seeing is a 500-year riverine rainfall-induced flooding. We've got coastal flooding. We got drought, wildfires, energy demand, extreme heat. What we did was bring in from public databases all these other infrastructure layers. So we got essential facilities, we got lifeline utilities, roads, buildings. And what we can do is intersect that hazard, in this case, the riverine flood inundation, with one or more of these infrastructure layers. So for example, here you can see maximum 5-day rainfall, the number of percentage of roads within grid that's going to be impacted by that flooding. And you can click on these structures and the infrastructure systems that are there, buildings or whatever. Let me see if this works. It'll tell you what that is. So this is the mayor's office. And the reason we created this was, again, because we're putting a lot of very expensive and mission critical infrastructure in here. So this tool is being used to make better decisions about where we put the DoD critical infrastructure within the island of Guam. So if you all do decide to use Guam as one of your case studies, I think this tool should be very valuable in just knowing all the hazards and making sure that, you're looking at the disruptions with infrastructure and like this, the office and the warehouse. Everything that's publicly available is here. This will become classified when we put in DoD stuff, but it should be good enough for what you guys have to do. If there's any questions, thank you for your time.
So this is fascinating. This brings together what you're just saying, right, about the water resources and lifelines and things like that. So we have a lot of questions. We'll get back to you, including about you said this is unclassified, right? So can some of these data sets be shared?
This is all publicly available. We can even share the tool with you.
Oh, wow.
Log in a password too.
Okay.
Satish, did you have any closing comments? You're on mute.
Satish,
Satish, you're on mute.
Again, sorry.
the interest
Yeah,
of
I just want to thank Himangshu and Craig for joining in and chiming in on the stuff. It looks like was just a pretty good heated discussion, not heated, I would say good discussion on the topics. Some common areas to be pain points that we identified some other opportunities for data for Auroop and his team, I believe. So that's good.
We'd love to have you here at some point again. I mean, whenever things work out. And
Sure.
thank you so much for joining virtually, everybody. And of course, Himangshu here. Okay, so in the interest of time, Satish, I think we'll move on to the next panel, if it's okay with you. Can you hear us?
Yeah. You guys can jump to the next one. Thanks for having me.
Thank you so much. Sudershan, if you want to go ahead and share your slides while we're getting the next session set up, that would be great. Sam?
The next session is, I don't have my glasses, you just. No glasses.
So next session is on connection with other SERDP ESTCP. And the slides are up.
Thank you, everyone. So the next session will focus on synergies with other SERDP and ESTCP projects. And I'm delighted to have an excellent panel here. Sudershan Gangrader from the Environmental Sciences Division at Oak Ridge National Lab. He'll go first and share a little bit about his ESTCP project. And then Dr. David Alderson from the Naval Postgraduate School Operations Research Department. And also Dr. Dan Eisenberg, who's not able to join us here today, but both Dave and Dan lead and co-lead multiple SERDP projects with focus on installation resilience and infrastructure resilience. And what you'll hear from the panelists in this session is going to be a focus on, collectively where we stand when it comes to installation resilience and how far we have come collectively in terms of the work that's going on. Some projects that I mentioned here, they started around the same time as our NICE project. Some started just after. So want to hear from the panelists, their perspectives on where we are, how far we have come, and what are the next steps in terms of the gaps that still remain in terms of how we map research findings, operational settings, and missions. So with that, we'll go with Sudershan first. For the first maybe few minutes, Sudershan, go ahead. And
Sam, just sorry to interrupt. One quick interruption. So for everybody else, SERDP is more basic part of research within the SERDP ESTCP program. Of course, SERDP also has translational components, but relatively more basic. ESTCP is more translational, has some basic component as well. Sam, that's more or less right?
Perfect. Yeah, ESTCP is more on the applied side.
Applied side.
So we'll start first with Sudershan. Take it away.
Yeah, thank you, Sam, and thank you, Auroop, for inviting me. And hello, everyone. My name is Sudershan Gangrader. I'm a water resources engineer at Oak Ridge National Lab. And I am working on one of the ESTCP funded projects, which was started last year. And through the project, we are trying to look at the impacts of climate change on Department of Defense infrastructure. And in particular, we are looking at flood risks. So I prepared some material to guide the discussion, but at any point, if you have any questions, feel free to stop. So we all know that climate change is posing threat to the infrastructure, and DoD infrastructure is also among them. One of the recent DoD reports suggested that around 20% of their primary installations are vulnerable to flooding. And one of the examples we saw was in Offutt Air Force Base, Nebraska, in 2019, which got hit by the Midwestern flooding. About 1/3 of the installation was underwater, and eventually they had to spend millions of dollars to make a recovery out of it. In fact, so you see the images here, which show that the installation was underwater. In fact, this runway was also underwater. So it kind of poses threat to the operations of the Air Force Base as well. So through this project, we are trying to develop a framework which can help evaluate the climate change-based flood risks at selected Air Force bases. So we are developing a fully physics-based inundation modeling framework. So we are trying to integrate climate models, hydrologic models, hydraulic models, and come up with a more informed probabilistic flood risk assessments for these sites. And typically, in order to achieve this, you have to translate meteorologic forcings to hydrologic outputs, and then they get translated into surface water. So usually the computational bottleneck lies around the inundation modeling. And so in order to overcome that, we have developed a model called Triton, which is a fully physics-based hydrodynamic model. It's an open source model, and we solve full 2D shallow water equations. It can also address backwater effects as well as flash floods. In fact, we have also tried to demonstrate a test case for dam break assessments. But this model was developed for US Air Force under Oak Ridge National Lab and US Air Force R&D collaboration. And we are trying to utilize this model under this particular project. So in order to generate the climate-informed flood risk, we first want accurate hydroclimate projections. And in this particular case, we are leveraging our ORNL produced CMIP6 based downscaled hydroclimate projections. So we have these projections for the entire CONUS, and these are driven by 6 global climate models, and then they are downscaled using different statistical and dynamical modeling, modeling and downscaling and bias correction. And then they are then driven through hydrologic model. In fact, we use 2 different hydrologic models, WIC and PRMS. We are currently for this project, we are only sticking to WIC. And then the runoff from this model is then routed through the rapid model. So it produces runoff and stream flow, which eventually becomes the input for our Triton hydrodynamic model. So these are the 3 proposed sites. We are focusing on Offutt Air Force Base in Nebraska, and then McConnell Air Force Base in in Kansas, and then Maxwell Air Force Base in Alabama. So we try to create our hydrodynamic model setup over the Air Force Base, and then use these hydroclimate projections to generate different climate scenarios of flooding for these locations. So this is an example of how the simulation results look like for one of the events. And this is just for the observed data. So this is for the 2019 Midwestern US flood. And what you see here is in blue, the simulated Triton flood inundation extents and water depths, as well as in the red, what we are trying to do is compare it with satellite-based imagery. So this grid is around 8 million grid cells, and we run a 5-month-long event using the GPUs on Air Force's HPC machine. The model is really fast, so you can see that we can compute 1 day worth of simulation in just in 100 seconds. So it can also be translated eventually at the operational scales.
And then we try to validate the model using some high watermarks data for the event. And generally speaking, our mean absolute error is less than 1 meter. So usually a good indicates a decent performance. Our hit rate is good. There are some false alarm ratio, one can say. But again, this is based on the satellite imagery. So it also has its own pros and cons in terms of calculating based on the algorithms from the Landsat data. But once the model is trained, then what we are trying to do is use this trained model and use all of our hydroclimate projections. So we select annual maximum events from every year, and for 6 climate models, 480 simulations. We run the entire thing for baseline and future. Our baseline period is 1980 to 2019, and the future is 2020 to 2059 under SSP 585 scenario. So then we create an ensemble of Triton simulations. Now we have completed the runs, but currently I'm not showing the actual results for the site. We want to get it cleared through the Air Force. But I want to present the results from our proof of concept study that we did for one of the sites in Southeast US. This is Conestoga River Basin, and we basically applied the same approach and published our results in one of the Natural Hazards Art System Sciences journal. So essentially at the end, what we are trying to create are maps like this, where we can overlay it with satellite imagery or infrastructure layers to identify the current flood risks as well as the future flood risk. Not only that, because we have these ensemble flood inundation maps, we can also generate probabilistic flood maps, as well as also do a grid-based fitting for every grid cell, thereby generating 100-year flood inundation maps or 500-year flood inundation maps, things like that. And then eventually, we want to provide these high-resolution inundation maps to the decision makers at installation level, so that they can plan accordingly, as well as because we are developing this entire tool on Air Force's HPC machine, they will be able to use the framework and run it with any different scenarios or inputs of their choice eventually. And then this is a proof of concept. So finally, our modeling framework will be scalable and can be expanded to any other DoD site, or actually any site in the US. And then we eventually plan to link these data in some sort of a visualization tool, like the one that was shown in the previous panel discussion. And so that we can disseminate the information not only to the installation level, but also to the surrounding communities. And again, this is a work in progress. We just started last year. So as we make more progress, I'll be happy to share more results eventually. And that's all I have right now. With that, happy to answer any questions.
Thank you so much, Sudershan. If there's a question or two.
Can I just take 30 seconds to introduce Professor Stephen Flynn, who has just joined us. Hi, Steve.
Right.
And if
Embarrassingly late.
he's the same Steve Flynn. Igor, where is Igor? Igor was talking about, I just talked to Steve and learned about resilience. This is the same Steve Flynn, my friend. If you
We've been learning from each other every bit of the way.
Absolutely.
And now we can learn from a guy who I learned from, David Alderson. I look forward, I'll be here through the dinner and look forward to a chance to chat with it.
And will you? Maybe one question in the audience for Sudershan.
So, I mean, if there is no other question, I have a burning question. Uncertainties. So this cascade of models you have built, each of them have different levels of uncertainties and, if you will, knowledge gaps, right? Basically aleatory and epistemic uncertainties. Now, and this cascade of models will build onto that, right? One on top of the other, cascading uncertainty. How to deal with that and still come up with a signal that also answers some of the questions one of my colleague Marta, I think she's probably not here right now, but one of the questions she had. So if you can give us, this broad community and understanding of in these kind of models, there's so much different types of uncertainty, and then one uncertainty feeds into another. how do you still come up with a signal in these areas that will be very helpful for all of us to understand?
Yeah, I think that's a great question. So the way, at least in this particular problem, we are trying to look at is, so we have different number of components, and every component has different number of realizations. Let's just say that. So let's say we have 6 climate models, then 2 different downscaling approaches, 2 different hydrologic models, and then a flood inundation model. So using the final output, one way would be to look at the, like, what fraction of uncertainty is coming from which component. So we have tried to do this kind of analysis in our other works, and what we have found is that generally the climate models, they represent the dominant factor in contributing to that variance in the overall spread of the outputs. So one should pay more attention to the selection of climate models as opposed to any other components. But again, this answer varies for site to site and depending on the geographic location. The choice of hydrologic models as well as the inundation model can also play a significant role. So that can be one way to understand, okay, in these realization, what is going on. And then typically we try to look at the median and then some spread across it. So depending on the decision makers, like risk factor, they can decide on what broad range of outcomes they want to work with eventually.
Thank you, Subhra and then Thilo, and then maybe.
Thank you, Sudershan. So I am one of those decision makers. Yeah, so nobody has the answer to that. I mean, there's GCM uncertainty, there's downscaling uncertainty, both epistemic and aleatory. Nobody has that answer. It just hasn't been done and people are working on it. I'm very glad to see that you took all the GCMs from CMIP 6. We've done very similar things with CMIP 5. We took all the 33 plus for CONUS. And we should talk because we're doing it auto route and Vic Rapid for all of CONUS using the CMIP 5. It'll be great to compare your results with what we're doing with the core. And also glad to see that you're doing it for Offutt. Offutt had a massive flooding, and so we're looking into climate attribution for Offutt Air Force Base. So thank you for doing all you're doing, and we should definitely chat.
Yeah, I'm very happy to discuss it later. And sorry, I cannot see you. So can you please introduce?
Yeah, I work for the Department of Defense, and I'm on the technical committee for SERDP CCP.
Okay. Thank you.
Subhra Misra.
Oh, Subhra Misra, sorry.
And also.
Okay, thank you, Subhra.
And also defense climate adaptation toolkit, etc. So this is a big thing that just happened, Sudarshan. He's saying he's interested.
We should definitely chat, yes.
I know that Chikkagoudar is in your team too, right? So he used to be a postdoc long time back when I was at Oak Ridge, and he's doing very well. So this is a wonderful team. Thank you so much. We had one maybe last question for this one, Thilo.
Yeah, Thilo Gross. So it's a pretty generic question, sorry, but there tends to be an economy of information here, right? The more information you try to get out of a model, the more the computational time increases, right? And if I understand you correctly, right, your question actually asks for very little information. What is a flood risk? But in order to get this information, right, you copy nature, you simulate forwards in time. And simulating forwards in time, you produce a lot of information at a high cost that you actually then only use very indirectly. So at some point, isn't it worth going to models which do something simpler that's not going forward in time and are much more efficient for that reason? It might be more inaccurate for the one scenario, but they would enable you to study much more scenarios, right? So, I mean, is there a point where kind of this copying nature, this almost a digital twin approach, becomes less efficient and going about it more abstractly?
Yes, I agree with what you are saying, but also at the same time, the computationally demanding part comes from solving 2D shallow water equations in this particular framework. And the reason we try to use a fully physics-based model because these Air Force bases are nearly like flat area, and you do want high fidelity models for that, for an accurate estimation. But yes, I mean, if we want a quick and dirty answer, maybe we can fall back to some other approach, and that might help us give us a first estimate. Eventually, if we want to do more accurately, perhaps we want to rely on more accurate model. But that's my take. Yeah.
Yeah, that's a good question. There are a suite of models in this kind of space, as you know very well, different levels of complexity, but we can come back to that. But Sudershan, in the interest of time, thank you so much. And we'd love to talk with you. And those connections that just happened are great. So I'll talk with you eventually.
Thank you so much.
Sam.
Sounds good. Thanks.
Thank you so much. And without further ado, Dr. Dave Alderson for multiple sort of projects and perspectives on installation resilience from the Naval Postgraduate School.
Do I need to share after I go into presentation mode? Why am I only seeing that?
Auntie, I'll go. There you go.
I need to share first before. So I am, okay, see, so stop share. It's shooting up there. Share screen. Entire screen. Okay, there we go. All right. Good afternoon, everyone. My name's Dave Alderson. I'm from the Naval Postgraduate School in Monterey, California. For anyone not familiar with it, the Naval Postgraduate School is kind of like the Naval Academy in Annapolis, Maryland, which has primarily undergraduates. We have primarily graduate students at the master's level. We're joint. We're actually only about 40% Navy. We've got all branches of service, including international officers. And so in the spirit of other projects in SERDP, actually, there are a whole bunch of things I want to tell you about. There are two different SERDP projects I want to tell you about, both of which are done with my colleague, Daniel Eisenberg, who had intended to be here, but right now he's actually in 29 Palms for a pull the plug exercise, one of these black start kinds of things. So we do a lot of work with real military installations. Right now, we've got some engagement with Marine Corps Installation Command in Southern California. And so Dan is sorry not to be here today. So the first one I'm going to talk about, so I want to talk about two SERDP projects. And based on conversations, if we have time, I want to talk a little bit about different notions of resilience and how there are trade-offs between them and how that's practical in the context of work that we've been doing in the recovery of the U.S. Virgin Islands after the 2017 hurricanes. And then if we still have time after that, knowing that we've still got one more speaker today, I want to talk about what I think is broken in the research enterprise for critical infrastructure and where I think we ought to go. So if we don't get that today, maybe we can find that time for that tomorrow. Anyway, this project, which has focused on, in some sense, on compound threats like we've been talking about, has strong components, both what we say, inside the fence line as well as outside the fence line. So military installations are embedded in communities, and as much as commanding officers like to think that they have autonomy over what happens inside the fence line, not surprisingly, they're very dependent on what happens outside, and oftentimes these are things that are outside of their control. So we'll talk about both of those kinds of things here. The first, inside the fence line, I want to talk about prioritization of assets. So as Craig mentioned, there is a lot of tension and a lot of competition for limited dollars to be spent on installations. And one of the ways there are sort of a couple different key things that are used. There's something called condition index. That's the quality of the assets, right? How degraded they are. And then there's something called mission dependency index, which is how important these assets are to various missions. These two things are used in combination to decide whether they should be prioritized for sustainment, or whether they should be invested in, or whether they should just be divested and abandoned. These criteria are used to drive billions of dollars of maintenance and investment on an ongoing basis. So I want to talk a little bit about the mission dependency index and how it's badly broken. So one of the things that we do at the Naval Postgraduate School is we like to red team infrastructure systems. We also like to red team decision criteria and decision frameworks, which are often quite flawed. And this happens to be one of them. So the mission dependency index is something that combines expert elicitation that then gets normalized into an integrated scoring routine and then guides these kind of funding decisions. And so it's the kind of thing where folks on the installation will come up with, for a given mission set, the different assets on that installation and how they contribute. And so the way that this works is you may have multiple missions which have assets that are interdependent with one another. And in reality, this process that we go through creates implicit networks that are not explicitly laid out and nobody actually knows about. And these networks that get built are incomplete, inconsistent, and can lead to kind of arbitrary decisions at the end. So in particular, what happens is that there is an expert elicitation that starts with, a list of assets and some mission set, and then some kind of expert elicitation that gives you some kind of qualitative score for the importance of these things. And then there is a process by which separate elicitation talks about the relative importance between these different missions, again with scores. And these things get combined together in ways that don't necessarily map directly to the underlying physical systems, right? So we may have administrative missions, we may have, various kinds of flight mission sets or other kinds of things, operational things. And underneath the hood, there's electric power, there's water, other kinds of things, and they're not necessarily related to one another. And the other thing is individual assets within a mission don't necessarily reflect the kind of dependencies that exist in the physical world because of the way these things are built. So effectively, what we're doing is we're building networks without any real explicit structure or design behind them. The other consequence of this is the way in which people choose different mission sets can actually lead to different scores. So in this particular case, imagine that we have a fueling mission on an installation that involves some number of tanks and a pump station on the pier, control center, various other kinds of things. It turns out that there's a lot of discretion about the way in which these mission sets are defined and broken up. And so the point is that the same set of assets, if they were to have been grouped differently to begin with, could actually lead to totally different scores that might put them above or below investment thresholds. And so this kind of thing is problematic, right? Because you could have two well-informed, well-meaning folks who come up with different priorities, even if the same kind of scores have been assessed. Not to mention the fact that this also creates all kinds of opportunities for gaming these kinds of systems. And, it's not at all uncommon that public works officers or others will try to find ways to prioritize the things that they think are most important, right? And so sometimes these kind of rule sets kind of work against us. So we found flaws in this, and yet it's something that continues to be used and is guiding decisions for lots and lots of investment. So we've presented this in a number of different places. We do a lot of work with on the NAVFAC side, the Civil Engineering Corps Officer School, which sounds very much like the counterpart to the school that Craig runs for the Air Force. And Craig, that'll be something I want to talk about with you. We've written about it. It's been published a couple of years ago in Risk Analysis. So if you want to read about that, you can do that there. For this project outside the fence line, there are a number of different things, but we'll talk about mission assurance for Marine Corps Base Hawaii, which is on the north shore of Oahu, and the way it's embedded inside of the community. So one of the things that has been recognized for a long time is that if so a community surrounding an installation is non-functional, then there are going to be problems on the installation, either because people can't get to work or people choose not to come to work because their families are in distress in some way. And in the North Shore of Oahu, where you have a lot of remote communities, there are a lot of issues there, particularly in tsunami and other kinds of situations where there can be problems related to the distribution of food, the distribution of water, and in particular, the distribution of food, water, and fuel. Those are the main things. So working not only with the installation, but also working with the state and the county, there have been various plans through FEMA to come up with pre-positioning of assets, something that have been called pre-covery pods. And so the idea is that you would put containers that would have these kind of either food or water assets that could be accessed by the local community. And the question is, where exactly would you put them? As well as how would you go about refueling? So if there was a large power outage, how would you go about refueling? All of the plans. So one of the things that we see commonly is that everyone's got an emergency plan. Everyone says, well, we're going to get the trucks to sort of deliver fuel, and every single organization on the island is going after the same 4 trucks, right? And so the question is, you know, will you really have access to those kind of resources? So in this particular case, we're building models based on potential locations that have been identified. Looking at the road network here, you can see on the North Shore how isolated the communities along there are, and then ultimately looking to also consider tsunami evacuation zones, vehicle access, and considering potential different models. Models that would include either a pickup model, you would have centralized locations within the community where people would drive to go pick up their food, pick up their water, or to have delivery types of models where you would actually drive around to neighborhoods and deliver them to maybe vulnerable populations or others who can't do them on their own. It turns out that, you know, there are different views at the county level, at the state level, and then DoD in terms of how this all should work. And so, you know, the team was there trying to support this with some real analysis. One of the things that did come out is that there were some locations and all the scenarios that we looked at came up over and over again, right? So when you're looking at lots of different solutions, different scenarios, and it's all pointing to at least some of the same things, you can feel comfortable, at least in some way, that these are good decisions. And these things have been embedded into some of the state plans that have been put forward. Okay, as always, one of the things, as much as we think, you know, we like to work independently, we're heavily dependent on state and local, and so it's really important to be involved in those kind of conversations. So this is a project that actually ended last year. There are other things we have done, evacuation planning in Newport and other kinds of things, and the reports are all available. So I'm going to pause with this one to see if there are any questions while I transition to the next project. I should have asked, can you all hear me online? Sound check?
Sure can.
Thank you.
Yeah.
Okay. Question.
Just had a quick question. So what were the major takeaways from that project, the concluded project? You mentioned reports.
Yeah, well, in this case, I mean, some of the recommendations of the analyses. So a lot of the analyses were done in master's thesis by our officer students. Some of those recommendations made their way into the state emergency planning plan. Right? So those are concrete outcomes that we like to see whenever that ends up happening. Thank you for your question. Okay, so transitioning to another project that we have going on. This is one that I'm actively leading and currently, so this is being done with a whole number of folks, including not only Dan, but Rudy Darkin, a colleague in computer science, and Tom Seeger at Arizona State. We are currently, what's that bottom? Does anyone know why that bottom bar is still there? Just chill out. And, yeah. So we're just in the start of year 4 of a 4-year project. So we've been doing this for some time. And the starting point here, not surprisingly, is, well, we're living in a world of surprise. At least that's the argument. So what I'm showing you here at the start, these are 2 things that the same week in 2020, we had simultaneous tropical storms forming in the Gulf, and it seemed like the entire state of California was on fire. And in both cases, these are things that have kind of been unprecedented. You see things like the governor of Louisiana saying, we've never seen this before, we don't know what to expect. While in California, coming off of years of drought, the fact that there might be a lot of wildfires is not surprising. What was the timing of it. It was much earlier in the season than we had ever seen before. And we keep seeing other kinds of things, right? So deep freeze in Texas that causes unexpected things. It's all leading us to this notion that, you know, what we're going to see in the future is not going to be like the past, right? Stationarity in some sense is dead. So, you know, if you, so this is from NOAA's $1 billion disasters, right? These things, if you go there, you can get all kinds of data. The trend is upward, right? Both in terms of the counts and the cost. And this is causing real problems on military installations. So we have a technical report out of a postdoc who cataloged on the order of about a dozen different climate-driven disasters to kind of at least, you know, what happened and what was going on and what were the impacts, both in terms of mission and cost and how long it's going to take. And we can give you those things if you're interested. I'm not going to go through everything on here, but, you know, some of the main takeaways is that these things are happening now, right? This is not a future problem. This is a now problem. It's happening inside and outside the fence line. Again, we don't control what's outside the fence line, and what happens outside the fence line may directly impact what we can do inside the fence line in terms of being able to mitigate them. These, you know, each individual incident is complicated and sometimes only fully understood in hindsight. And so this is all leading us to this notion that surprise in some sense is inevitable. And so how we prepare is sort of as important, or how we respond is as important as how we prepare. We have another study that's in the process of peer review looking at Hurricane Michael and its impact on Marine Corps Base Camp Lejeune. You know, this is the kind of picture that we saw earlier in terms of a system and how it recovers. And what we kind of expect, you know, so we know that various things happen, it hurts us, and we're taking these kind of activities and we expect it to come back. What we've cataloged here are situations where actually things didn't come back quite like they thought, or they came back and then they got worse, right? Things like, you know, reopening buildings only later on to discover that they were full of mold, or taking action that is in fact not helping things, but actually making things worse. And so where does surprise occur? So surprise is the theme of this project. Where does it occur? It occurs in these events that challenge us. That certainly is the case with these unprecedented events. But what we see as much is that they occur in our own understanding of our own systems. We don't understand our systems as well as we think, and they don't respond or can't do what we think they can do. It's not just that it occurs for installations, it occurs for all systems. It's not a failure of knowing enough, it's that things are changing. Any model, any mental model that we have of a system gets outdated in time as change occurs, right? People start making, you know, putting things in place on the civil engineering side, right? So, you know, so we know that the as designs are different from the as builts, and those as builts change over time, right? And they're often not reflected in any kind of formal model. They're in the heads of the people who are working on them. And so we want to try to understand what it is that we can do here about surprise. When we're surprised by these extreme events, things that fall outside of what we can handle, how do we develop potentially new theories as well as training and exercises that help us get better at dealing with this? So there are a few things that go along with this. One, I'll just say up front, we see this kind of rebound curve quite frequently. It's in the national academies. We have kind of a very emergency management definition of resilience, right? The ability to plan, prepare, absorb, recover, and adapt. I mean, it's like the 5 phases of emergency management right there. We would argue that this is not a helpful model of resilience in a couple different ways. One, it confuses processes and outcomes. So this is a sort of a well-known confusion in cognitive science. While this might say like what happened, it doesn't tell us anything about what the activities were, how much effort was going into them, what actually worked, what could be done better. It doesn't capture at all the notion of a near miss. You could have a near miss that looks perfectly flat, where people, rose to the occasion and saved the day. Where's that in this kind of a framework? So we would argue that this kind of framing for resilience oversimplifies and reinforces misconceptions about what resilience even is. It's not helpful for understanding complex systems. We would argue it's potentially dangerous for guiding decisions. We've got a working manuscript on this. If anyone's interested, I'd be happy to send it. So when we're surprised by these extreme events, right, how do our systems respond? Are they going to have brittle collapse? Are they going to be resilient in some way, right? And so what we try to focus on is instead, we would actually prefer we don't use the term resilience. We would prefer to focus on adaptive capacity. I think it's maybe a little different from the notion that you mentioned earlier, but what is the potential of the system to change its activities, to change its behaviors, reconfigure the system when it is challenged in some way? Potentially when you can't even specify the challenge completely in advance. This is the thing that we want to try to work on. We would argue that there are some well-defined processes that are involved, and that in fact you can look at systems that are brittle and fail, or those that actually successfully adapt in terms of the success of these kind of processes. And again, we've written about this and I'd be happy to share it. I want to talk also about another notion here of surprise, and it's relevant for the machine learning, artificial intelligence perspective. So cognitive scientists have been talking about different types of surprise-related events going back to at least the 1980s. And so I'll distinguish 3 different things here. One is what we might call normal variation. These are the fluctuations that we see during a normal, daily, weekly, seasonal kind of thing. And of course, those are changing over time. But there are 2 kinds of surprise events. So one is what we'll call situational surprise. These would be extreme events, things that are maybe way out in the tail of the distribution, but still generally fit with our understanding of the way things work. They're consistent with our model for how we think about these kinds of systems. And this is different from what we'll call fundamental surprise, which is a fundamental surprise when it occurs requires you to rethink how the system even works to begin with. It requires a reframing of what the system is and what the system does. Now, Dan's come up with a really nice example to kind of frame this. And the example is one of buying a lottery ticket. Right? We've seen the lottery, the prices going up crazy, hundreds of millions, billions of dollars. Right? I don't know who's playing the lottery. I'm not playing the lottery. So what's the normal variation, right? Normal variation with the lottery is that you buy a ticket and you lose, right? That's kind of what we always expect to happen, right? Mostly that's what happens. Situational surprise is you buy a ticket and you win. Right? I mean, a very rare event, right? But somebody wins eventually, and maybe it's you, right? But still, it means the way the world works is still kind of makes sense. What would fundamental surprise be? You don't buy a ticket and you win. So if that were to happen, you'd be like, oh, I clicked on a website that entered me in a thing that put me in a pool that I want, like, you'd have to reimagine even how this sequence of events could have even gotten you there. And as much as anything, we're starting to see a lot more instances of fundamental surprise. And so the question is, how do we prepare for them? So the thing with, and we got a paper in risk analysis on this, better machine learning techniques, right, will be helpful for situational surprise where we've got this feedback loop. We can update our prior probabilities. We can do this kind of thing. It's not going to work for fundamental surprise because fundamental surprise operates on the mental framing of the decision makers who are actually trying to deal with things. And we don't yet know how to create algorithms that can reframe the problem that they're trying to solve. So open problem, challenge for you. So the question is, if we want to try to develop tools, exercises to get better at all this, how do we do it? Right? So models and simulations are relatively easy. They require relatively little expense in the grand scheme of things, but they can only kind of build in the things that we've modeled, right? The fluctuations, maybe the extreme events. At the opposite side, right, live events, right, when we actually have to deal with the thing, these are quite expensive. So the intent here is to think about a sweet spot in the middle involving games and exercises where we can try to exploit this. And so one of the things that we have done is we have developed a sandbox style virtual world that we call Dystopia. It's got geospatial layers in it. It has towns, it has roads, it has military installations. We have elevation data, we have temperature data, and we can geolocate this anywhere in the world. So I had a student just last year, he was from the big island of Hawaii, so we located this thing as kind of like, you know, the next big island in the chain, right? And so having done this, we could now throw various things at it. He in particular was interested in wildfire, and so he was doing wildfire simulation and looking at the impact on both the installation as well as access to the installation under future different climate scenarios. So as things get drier, how much more frequently would large fires potentially be? We've also been doing things like building realistic infrastructure systems. So we have another student, civil engineering course, CB. What she did was she built, well, she visited a whole bunch of real naval military installations and came up with a power grid that is fake, it's synthetic, but in the sense that it doesn't represent any one real place, but shares the features of real power systems. Installation power systems do not necessarily look like the ones that we see in the civilian world. And so the idea is that we can put these kinds of things in dystopia and have systems that are both geographically realistic as well as functionally realistic and start to do simulation as well as games. And so one of the things that we've done is we've built an online game called Disruption, which takes place in the island of Dystopia. And we have students play 3 different games. The first is called Break It Bad, where they essentially get to be an attacker and red team a fuel pipeline network. So thinking about how you can, with limited attacks, interrupt flows, even when the system reroutes the best that it can. This is all based on the network interdiction, attacker-defender, defender-attacker games that Craig mentioned that MPS has championed over the last 20 years or so. And so they get to kind of experience that. We have another game called Fix It Fast, where they inherit a broken system and they're trying to get it back up as quickly as possible. And then the really fun one is a game called Save Our System, which is a multi-turn game. A multi-turn game where they are they have to make decisions in each turn about, do they want to do preventative maintenance? Do they want to repair or replace things that are broken? And we're dealing with component degradation, right? So things are aging with each turn, which is increasing the failure probabilities. And how do they manage these kind of decision sets under both budget and time constraint? We've now held more than 18 different training sessions, both in the classroom, the Center for Homeland Defense and Security at the Naval Postgraduate School, where we're teaching primarily emergency responder, police, fire, FEMA kinds of folks. We've been doing a lot of work with Naval Facilities Command Civil Engineering Corps Officer School. This is the counterpart to what Craig mentioned for the Air Force. This is continuing development at different stages of public works officer's career. And then most recently in October, we were in Lublin, Poland, holding a week-long class where we were teaching the Ukrainians, essentially their DHS in charge of their critical infrastructure, about how some of these tensions as it pertains to critical energy infrastructure protection and resilience. Folks seem to really like this game. It's amazing how, just the experience of being able to break things and see the consequences is so much more effective than, me giving all kinds of lectures about what matters and how to think about it and these kinds of things. So as part of this, we've also been thinking about what are the sources of surprise. We've come up with a typology for different ways in which people form expectations, and those expectations might be wildly wrong. And so the, kind of wrapping up here for this project as we're going into our last year, the big question is, how do we become prepared to be unprepared? We're not going to be able to enumerate all the scenarios. We don't know our systems in their entirety, right? Certainly all of the kinds of modeling and simulation things we've been talking about today, those are important, but they're incomplete. We are not going to think about everything ahead of time. So we need a new theory of surprise, and we need new exercise and training kinds of tools. In our last year, what we're primarily focused on is creating novel scenarios that are more closely tied to climate surprise. Right now, we've got other things related to large-scale failure and recovery. This is the last piece. So we've published a few things all related to this. We have a number that are in peer review right now. And if you're interested in that, I can send you some things. So let me pause there. See if there are questions.
Let me quickly start with two, just to heat the room up a little bit. This is very provocative. I love that. So first question, and please, you can listen to both at once and then ask. First question is surprise. Let me put on my traditional academic hat and say this has been done for the last 100 years. It hasn't, but I'm just saying. So how is this different from nonlinear or what some people call non-stationary extreme value theory? You have designed something for 100-year return periods. Those return periods change over time based on climate change. This last presentation was by Sudershan, who was one of the, partners there. He has done this kind of work. Others have done this kind of work for a while. So if you have designed something for 100-year return periods, you've given a safety factor of 2, at some point that safety factor will be overwhelmed. Hence that dam will, whatever you have designed will break. And you can progress in time. So there is surprise, there is transformative surprise. So for all of us here, as we are trying to understand, how would you differentiate that from what you are saying here, right? So that's one question. Okay, let me ask you both and then you can answer both. The other question is your slide number 10. Where you say that this concept of resilience is wrong. Does that mean my friend Steve Flynn is wrong? I'll leave it out.
I like where he's going.
What made you think he was right?
Exactly.
So we'll take the second one offline, maybe over drinks tonight. First question. So what you've described, I think, is entirely consistent with situational surprise. Right. So the fact that you were having bigger extremes that maybe you weren't designed for, or maybe you didn't think you had to design for, right? Over time, we know these things are changing. What we see after the fact, more often than not, the comments that we didn't realize that this thing depended on that over there, right? These hidden dependencies that exist in our systems that actually can quite profoundly change the way that we think about, that we manage that this kind of a thing, right? So those kinds of things are going to continue to happen. And there are no techniques to just, perturb an existing system and try to discover these kinds of things. So I think that's what I would say. Fundamental surprise is different. Now, what's interesting is if you do we've got a paper we're trying to finish that tries to, look at all the different literatures that have studied surprise. They're all kind of very inconsistent with one another to begin with. But there's also, there's a human emotional component to surprise. That's there as well, right? And actually, there are some really interesting connections to resilience and adaptive capacity, and this notion of, either a brittle shock, maladaptive kind of response versus the more adaptive, productive kind of response. So things that we're still working out there. Yeah.
Steve Heddigley.
Steve.
Yeah. We can have, I like going, the evolution towards adaptive capacity, I think is the right one. And I could go, the earlier history of the curve was in no small part just trying to break the mode. It was trying to solve a different problem to some extent. We had isolated efforts to deal with prevention, isolated efforts to deal with response, isolated efforts to deal with recovery without anybody looking at that. There's an overall goal here, which is to recover function. And to some extent, getting people just to see that forest for the trees was a little bit what that very primitive, chart did. But it certainly had unintended consequences the way that you've laid out. So I wanted to pull something out of the headlines and ask how the analysis, particularly that you said could have helped us out or helped certainly the Maryland Department of Transportation out on. Right. On its face now, we could look at the collapse of the Francis Scott Key Bridge.
Yep.
As something somebody should have identified as worth investing in greater protective measures for. And yet nobody saw it until it failed, right? So at its core, the bridge falling into the navigable channel, closing down the entire port of Baltimore with all the cascading consequence, made that bridge more important than other bridges that the Maryland Department of Transportation was making. We see that now at the benefit of hindsight. But that's not how they were looking at it. They were looking at how many vehicles are going, its relative conditions and so forth. How would the tools that you've been trying to develop, the risk management to allow them to have thought about risk relative to bridges differently?
So that's an interesting one. And I'm not expert, so I'm going to talk just from what I see in the headlines and have read and how I think about it. The bridge didn't fail on its own, right? Something ran into it, right? Okay. So why did something run into it, right? So one, there were no tugs. Right? Why were there no tugs? Because there were some new abilities, new technologies that had been introduced to allow these ships to maneuver in a way where they thought it was no longer necessary to have tugs in the way that there used to be tugs, right? So what you really have is new automation that has come in and created a new vulnerability that folks actually didn't realize, such that when that new technology failed, we have a new failure mode that we didn't see before. So this is kind of the robust yet fragile kind of idea where you introduce a technology to try to make things either faster, better, cheaper, or more robust in some way, right? The ships are more navigable. There's more automation on the ship. We don't have to have the same skill sets that we used to have maybe in pilots or other kinds of things. And that's all great until it fails. And we don't have the things in place to kind of recover. So I think that there are things to be said about it. I don't know that it exactly aligns with what I had in those in that slide.
So I know it is not an easy answer here to this, but whether how much of that surprise should have been a surprise and the rest of it is, but it strikes me as it's a very real world issue of missing yet again a major risk that has had significant cascading consequences.
Yep.
And the people who are assessing risk relative to a critical piece of infrastructure, but once again, it's blindsided. And I think your goal of your work here is right, is try to get out in front of that. But we have to have tools, I think, that help to deal with this very siloed approach to assessing risk. Where this silo is primarily around a department focused on bridges as conveyances for vehicles going across those bridges.
Yeah, I mean,
I'm seeing it as a part of a interconnected system.
So
which depending on the bridge, would cause more cascading failures, leading one to at least begin the process of reassessing
Yep.
risk and so forth here, right?
So,
What goes on out there is the bottom line, because we're keeping it blindsided by these real world
yeah,
events.
I mean, I think that, the pattern that I see playing out, right, is one where a technology is adopted. In this case, it's a technology that involves, to some extent, more automation. And the adoption of that technology incurs risks elsewhere that maybe we used to be aware of, but maybe we now start to discount.
Yeah.
Right? And so I don't know that we're ever going to get to the point where we can identify all of those kinds of things. But the question ought to be, or a question ought to be, right, as we adopt these new kind of trends, these new technologies, what risks are we perhaps taking on that we're not aware of?
Right.
And that's a thorny.
And then how to prioritize relative to an inventory assets,
Yep.
which deserve more care than others.
I know we're short on time.
Which makes me think, Steve, our that critical infrastructure textbook that we co-wrote needs to be updated.
I have one more quick story that I want to tell, but yes, Dr.
Before that, I'll make a comment on that because I used to work in the marine industry. There's a lot of things here, but my assessment is that this was somebody with a low risk or higher risk tolerance and negligence. If they had put fenders on the piers,
Right.
even with the impact would have been fine. If it was an LNG carrier instead of a container ship, they would have been mandated to use tugs. So there's a whole bunch of things. This is the known. This is not a surprise at all. So,
Yeah.
but anyway, that's it.
There's two questions together, one from Craig and one from Thilo, and then answer them.
Okay.
You will, and then let's.
Yeah, Craig, you're up.
Craig and then Thilo.
Yeah, absolutely. I think this is fantastic. And so I think it reinforces some of the things we were thinking here about this idea of models as a learning tool versus a planning tool. And so I guess how do you get any comments on how this works to bridge that gap as a learning tool between those functional levels? So specifically mission owners versus the public works owners or others, and how maybe establishing common knowledge can be useful as opposed to just the infrastructure owner. And unfortunately, I hope you got a great answer, but I'm going to have to log off for another meeting here. I look forward to talking more about this. Thanks.
So,
Thilo, and then you can answer together if that helps.
okay, sure.
Thilo, please.
Yeah, I mean, thanks very much for the talk. It was very interesting. First struck me that your three categories of surprise are really the Rumsfeld distance. I think we have heard this in the previous comment, right? It's that kind of fundamental surprise are the unknown unknowns, right? At least the flip side of that. But then if you're in your game, right, you don't quite go to this level. You still have a model of the system which obeys certain rules, and then you are again only thinking about in terms of these rules. In principle, you could make another game, right? Because truly we have this already. That's what science is, right? In physics, you make a model of the system, and then you try to break the model to analyze the failure, make a better model. And this is how you explore other possibilities that could happen, right? And in principle, you could also gamify this. You could say one player says, this is what I believe what is done. And then the other player said, well, you're based on these assumptions, and these are the ways in which the assumptions could be wrong, right? And you could do that back and forth and use this to explore the space of possibilities that nobody has thought about.
Yep. So I'm going to take that offline for later, because there are all kinds of really cool game ideas that we've thought about that we could talk about that are in there. But there are some things that we're working on this year to maybe start to get at maybe a little bit of it. In answer to Craig's question, it's kind of like baby steps, right? So right now, at least on the NAVFAC side, we're only dealing primarily with public works kind of officers to get them to be thinking about systems in maybe a different way. We have ideas for things that would involve having to deal with budgets and different colors of money and what you can do. Maybe having a headquarters that's in charge of allocating limited funds against competing installations who are both asking for money, and so trying to get them to understand some of these trade-offs. So there are a number of interesting things where I think that this can go. Okay, I want to just tell one more quick story. But it's relevant for, I think, a lot of the conversation because we've been talking about resilience kind of like one thing, and it's many different things, right? I mean, as defined by that, definition of essentially attach all the emergency management frameworks, right? So anyway, Dan and I run a center at NPS. So what I want to talk about here is hurricane season 2017. It was mentioned earlier today. And in particular, the U.S. Virgin Islands, which are down here next to Puerto Rico, about 1,100 miles from Miami. Never knew it was so far, right? You can fly all the way to Miami, and then you get on a plane, and you go like another 2.5 hours, right, to get there. So in 2017, there was Hurricane Harvey, which dumped a ton of water in Houston, but there were two other storms. One was Hurricane Irma, that a lot of people heard about because it went up Florida. And then the other one, 2 weeks later, right, was Maria that everyone heard about because it hit Puerto Rico. But where those two storms crossed was the U.S. Virgin Islands. So 2 Cat 5 storms in a 2-week period of time. In fact, what happened after Irma, because St. Thomas and St. John had gotten hit, St. Croix sent all of its emergency stuff there, and Puerto Rico sent all of its emergency stuff there. And then those two places were now vulnerable, even worse, right? So I want to talk about 4 distinct notions of resilience. And here I'm going to borrow from, I don't know why this bar is still, 4 different notions of resilience, 2 of them that are going to be familiar, and then 2 that are maybe less familiar. Rebound, right? Bouncing back from traumatic events, right? That's what that curve is really meant to show. Robustness as well, right? Being able to withstand, maybe not having that dip go down at all. But there are 2 others that I want to introduce. One is called extensibility, which is essentially the ability of a system to stretch beyond its original design, possibly by reconfiguration, in order to meet some near-term goal, as well as longer-term adaptability. And so in particular, there are 2 papers that I can refer to you. One is by colleague David Woods at Ohio State, who's really big in the resilience engineering community. He first outlined these 4 things, and then Dan and I have a paper that appeared in Networks where we try to make these things a little more mathematical. So I want to use the Virgin Islands to illustrate these 4 things because number 1, they're different. Number 2, because they're different, there are trade-offs between them. Investing in one might come at the expense of another. And understanding these kind of trade-offs is important for how you think about limited resources. So we'll use a familiar picture. We got time going from the left to the right. There is some stressful event, and robustness is, right, the system continues to work the way that it was working before the stressful event, right? We withstand things. Rebound is, well, we're going to return to some previous function. So what does that mean in the context of the Virgin Islands? Well, in the Virgin Islands, 90% of all the power poles got ripped out by these 2 storms. And so what they said is, we need stronger power poles. FEMA endeavored to buy these composite power poles that are exquisitely expensive, tens of thousands of dollars per power pole. So that, the total cost of this installation was, hundreds of millions of dollars. Now, these power poles are rated to, 200 miles an hour. Like, wind will not take these things down. They are as robust as you might expect. But a caveat is that they are, really expensive, hard to manufacture, hard to install, and hard if you have to deal with them. They're really, because they're so strong, it's not like you can just use a chainsaw and cut one down, right? Okay, so that's robustness. What's rebound, right? Line crews. Right, so the power lines go down, we send trucks out, we get them back up, right? Those are the 2 things. Now, the problem is that even if you prepare in this kind of way, you can still suffer surprise. And in particular, what happened was they had put these power poles up in St. John first. And one day they went to bed. There was a tropical storm to the south of them. They woke up the next morning, and there was a Category 1 hurricane over them, Hurricane Dorian. And Dorian was known because it went north and did even worse stuff. But there were some composite power poles that went down in this Category 1 storm. Why did the power poles go down? Turns out that they're rated for wind. They're not rated for debris strikes. So when you put them up in a forest and trees get picked up and start flying around, these power poles get knocked down. And once they're knocked down, the locals do not have the ability to cut them down to maintain them or do anything else. So the investment in robustness means that you are actually less recoverable than you might have been. Plus, of course, there's a trade-off in budget. Okay, so what are these two other concepts here? Extensibility and adaptability. What's extensibility? Oh, so I should say these two rows. This first one, we kind of think about, this is really focused on keeping things the same, right? Either we're going to withstand and stay the same, or we're going to bounce back to being the same. The second row is really about embracing the new, right? We're going to do things in a different kind of way than we're doing it right now, short-term, long-term. So what's extensibility? Well, it's generators, right? Which have become quite popular. Let me ask you a question. Does having an emergency generator make you resilient?
Yes.
I'm going to say no. Because if you don't have fuel, if you haven't maintained it, if you don't know how to use it, having the generator doesn't actually make you resilient. It's being able to put the generator in service that ultimately matters, right? So we're fond of saying that resilience is not about what you have, it's about what you can do. Resilience needs to be thought of as a verb, not a noun. It's not about having, it's about doing. And for that reason, Dan and I have a little bit of a pet peeve. We really don't like the word resilience. You could strike that from your vocabulary. They're often used interchangeably, but the resiliency is very having. I have resilience. No. I am resilient because of the things that I can do. Okay, so that's extensibility. What's adaptability? Well, reconfiguring the system, right? Building a new combination of generation and storage and other kinds of things, and these things are happening in the Virgin Islands, not surprisingly. So, 4 key concepts of resilience. They are different, and there are trade-offs between them. If you invest in one, it might come at the expense of another, either the literal expense because you've used up your budget and you no longer have it, or it actually might make some of these other things more difficult. And so when you think about what the priorities are for investment, you should think about these trade-offs. It's not that there's only one or there's only one right answer, right? It's just that there are different things. And focusing only on one might make you blind to the others or might come at the expense of another. So we need to be aware of the trade-offs, and we need to be really aware of simple scoring mechanisms that try to put these things into a simple number that rack and stack. We really don't like that. So with that, I really will stop. We've written about these things, at least the 4 notions, and you can download those at my website. Otherwise, I will pause here.
It was really fascinating, Dave. Maybe a question from the audience?
One question, yes.
A quick comment, because you brought up resilience twice. You look at the DoD definition for 15.21.
Yeah.
Specifically, it says adapt to changing condition. We try to make people build back better and smarter and not do the same thing and
Yeah. Definitions are really hard, right? Because we're using English words to kind of, and things get really conflated, right? But I'm pleased to hear that.
Very pragmatic comment. I agree that resilience is not optimal. There are many shades of gray around it, but at least now we have National Resilience Plan. We have resilience written in government structures. If we start to use anti-fragility, God knows what.
I definitely don't want anti-fragility.
It will be, but some people trying to. It will be even more confusing. I think, even though I appreciate, and my first paper on resilience was exactly along these lines with Tom Seeger, actually, I think as a scientist, we should kind of get behind what is reasonable if we like to make government moving in that direction. So I think the danger of kind of, you know, all these different directions around resilience umbrella is that it's not that it's scientifically credible, but rather, do we like to make things happen? Do we like to change? We're stuck in resilience risk universe.
Fourth time right there. But I should pause, I think here. I don't know. I have a direct response in the form of about another short slide deck. So where we need to go, but you've all been really generous with your time tolerating me.
Could I make one point, which is where I think element of, you're leading with Igor here, sustainability versus resilience. One thing that resilience has helped, I think, to get people to think about is some of the things we do for sustainability could introduce more fragility.
I would say that sustainability.
What's that?
With that,
Sustainability is a type of resilience.
Well, that's, so I mean, this is key here, that we're thinking now more robustly about terms, trade-offs with the tools that we have, with the limits of language.
to the extent we can be anti-fragile with time. So you can ask your question. Meanwhile, maybe Subhra and Todd, where's Todd? Oh, Todd.
I yield my time to Todd. All my time
We
yielded.
can always carry these conversations to dinner.
Are you sure?
Yeah.
Well, we want to hear from you.
Okay.
Hard enough for me, so.
Okay, all right.
True.
All to Todd.
We can carry these conversations over to whatever beverage you are all interested in. But question, you.
All right,
Okay,
nice.
so just to round off this panel, just a round of
I'm
applause.
gonna take you up.
If you will ask your question, Jamshi.
Oh, yeah, Janshi.
So as I also mentioned, there are a lot of definitions of resilience.
Yeah.
So in your presentation, you mentioned about the robustness. For me, that is quite related to the resistance. So it's like keep its state like a wall, right? If you make the wall like using the some materials, then that will not shake, right?
Yes.
But it's not resilient because if
I would say that resistance is a type of robustness.
this is what yeah.
Yeah, so in earlier work, I mean, we can define robustness in a control theoretic way as, you know, the persistence of an attribute of a system to some well-defined set of perturbations. And where that ends up being different from a resilience is that typically you want to define the set of perturbations.
Thank you so much. And again, there will be beverage for more heated discussions. So let's be.
Resilience.
Yes.
Here's to that.
It's a pleasure to introduce Dr. Todd Hay, who is at Pacific Northwest National Laboratory, but based in Boston, and DoD climate adaptation scientist. So we are very looking forward to listen to him, and I'm hoping, Subhra, that you yielded your time to ask questions. Please do. Love those questions. That's why we are here. Otherwise, like I was telling you, we could do this in our own labs, right? So these questions, and from all of you, we'd love that. So Todd, please take it away.
Great. And if I'm between you all and drinks, we are going to go quickly here. And so we do a lot of support for Subhra on the ECAT tool, so the DoD climate assessment tool. I'm actually not going to talk about that today. And if you want to, Subhra is really the expert, but we can surely talk. We're doing a bunch of kind of vulnerability, sensitivity, and adaptive capacity work to help extend that tool into those areas. I'm actually going to talk about a different project called Prepares, which touches on a lot of these similar themes, but it's different sponsor. It's still in the DoD space. It's a bit of a different mission area, but I'll take you for a little journey here. I'm also going to talk a little bit towards the end of just about what does it mean to actually try to deploy tools in the DoD spaces as well? How do you actually operationalize capabilities and get those into, you know, quote, warfighter hands? What does that mean? So, all right. So with that, we'll get going here. Okay. So DoD loves its OV1. It's operational view one. Very simple, right? We are trying to take the best in climate and weather modeling and trying to be able to project out into the future. And I'll talk about time scales and spatial scales in a bit. We're trying to understand what types of impacts on human and social elements that has, and then feed that into decision support tools, effectively, for a particular class of Army users, what are called civil affairs users out there. So these are small teams that go in country into foreign societies, and they have 4 mission spaces over there on the right, on the right-hand side. They will do everything from kind of pre-mission dare I use the term resilience or adaptive capacity building, should I say instead, maybe? They will do that in country. They will do help with civil military integration. They go what they call a civilian common operating picture. And I'll kind of go through those terms in a little bit here, but that's the goal of this particular project. This project is 6.2 applied research, so it's not the basic research, which is more conservative. This is actually trying to say, what can we take out there in the basic research and actually try to bring that to the end operational user. I would say one more thing about the fact that this is 6.2. So there's a corollary effort in the DoD called Minerva that funds social science basic research. This is actually an effort underway to try to take that basic social science research and actually apply that into the military context. So it's similar to how there's SERDP and ESTCP. It's basically Minerva and prepares as kind of an initial effort to try to take that basic research and get that into operational hands. So how are we thinking about the problem? We always start with data. We're working with the civil affairs community out there, and they think about this CivCop, and they basically divide that into two components. They have these physical infrastructure layers that you can imagine that they care about: food, water, power, transportation. And then they also have their what they call the human infrastructure layers. Think of everything from ethnicities, linguistics, religion, demography, economics, human well-being, et cetera. So we're definitely thinking about kind of data sets in terms of those terms. You have to imagine we're trying to do this overseas. We're not doing this at US bases, definitely not CONUS, not even US bases foreign. We're doing this in other foreign societies out there. So quality of data really varies significantly. We're not going to have high quality DEMS or things of that nature. So we kind of go with what we can get. The next bit is right now they basically take that data and they just kind of merge that together into a COP and they say, hey, there's our COP. Right? There's our CivCop. We have all these data layers and it's just kind of digital bar graph, essentially. We're trying to help elevate that to meaningful analysis, in particular in a kind of a climate and environmental perspective. And so we're looking at what are those key questions that they care about. Things like which communities are struggling due to a drought, what are the resource support organizations and resources that are local by that could help them, are there sufficient resources to cover down on shortages, et cetera. Then we're also trying to really understand what are those basic physical and social vulnerabilities and what are possible impacts resulting from those. The third piece of what we're working on is essentially engagement. So, and that for us comes in 4 different manners. One is we look at engagement for participating in their demonstrations. So we were just at their Project Convergence, which is a big kind of technology demonstration that they held at Camp Pendleton a few weeks ago. We'll also participate in exercises. They have an upcoming warfighter exercise that they're going to be doing with 18th Airborne Corps. And then the final bit is we're looking at how do we actually deploy this into their spaces. So right now we do our development on the AWS GovCloud and unclassified side, but we're also working with some particular units out there to try to deploy this on what's called the NIPRNet and the CIPRNet, the classified spaces as well. So we have used, basically, so I should mention, this is our first year of the activity. It's a 5-year effort. So we're about 8 months into this activity, but we're using a series of case studies to drive development. We started out with essentially 18 countries of interest. We wrote up kind of one-pagers, if you will, what we thought, hey, these might be interesting environmental or climate scenarios, demonstrating impact to military operations. So what might those be? We whittled that down to 4 countries of interest. We kind of end up focusing in the Indo-Pacific theater and the AFRICOM, or the Africa theater as well. Excuse me if I use military jargon here too much, but that's Indo-Pacific Command and then Africa Command. From those 4 countries, then we identified what were particular human domains, human kind of domain systems that they cared about as well. So things like agriculture, hydrology, et cetera. So we tried to hone in on particular areas we might actually go and analyze. From there, we've identified 2 countries and human domains. And finally, what we're in the process right now is actually doing that kind of the detailed engineering and data aggregation. These are the big 4 case studies we've been looking at. So we see the 2 on the right hand, excuse me, my right hand side are Taiwan and Philippines. Those are the 2 we're actively working on. And then the 2 on the other side, India and Somalia, those are kind of waiting in the wings to work on. These are really driven by our folks out there, the operational users saying, hey, where are areas that we kind of care about? But they also stress our kind of different potential climate impacts out there. So in the Philippines, we're really looking at a kind of a nexus between drought and water and energy and how that might impact certain semiconductor manufacturing, big strategic interest in that region of the world. Philippines, it's a lot more of a kind of a natural resource governance question as to how do you understand climate impacts, ocean chemistry, and to fish abundance and fishing abundance and distribution in that region, and how that might engage with certain strategic competition with other countries in that area. North India is more a human migration question. If we have, say, glacial lake outburst flooding, what happens in that region? And how do you deal with the human migration that occurs as a result? And then Somalia is more about kind of non-state government actors and what this notion of governance and legitimacy of different entities in a foreign region. So those are all four kind of like very different kind of impacts that climate might have in those regions. So kind of the general approach we're taking is we are starting with, and you have to imagine, you know, we're 6.2 applied research, so we're trying to take as much of what's out there right now that we can leverage. In certain cases, we'll build our own, but we will take models and capabilities and results coming from other folks like yourself as much as we can and do an integration across those. So I'll talk a little bit about some of the data we're using in terms of the climate and weather projections we're using. And by weather, I mean really the seasonal weather projections. We then look for physical impacts and vulnerabilities and impacts on certain systems. We then go into the social vulnerabilities and impacts. And for social vulnerability, we really identified three main sectors we're looking at. So there's certainly the notion of human well-being, which is a very murky notion, as you might imagine, if you work in that space. But we're definitely looking at the notion of human well-being, how that could bubble up into the term of social mobilization. So when you have certain disgruntlement, how does that actually manifest itself in, say, protests or changes in, say, political systems? And then the final bit we're looking at is this notion of foreign influence. When do you have foreign entities actually kind of meddling in the affairs of certain countries as well? And then the final bit that we consider is, okay, with all this information analysis, what could a civil affairs team actually do with it? How might we feed that to them? How might we, there's some interesting discussions today just about how do you convey this type of information to users actually, and how do they kind of have confidence in that data as well? So I'm very interested in some follow-up discussions that you were talking about earlier today, Lean. So if we think about this from a Taiwan perspective, what are we looking at? So we're certainly looking at certain climate and weather data over here. So things like precipitation and temperature projections. We've actually adapted the DCAT climate indicators over here as well. There are these 33 indicators that kind of do these, looking at some of the larger decadal projections and then trying to come up with certain indicators that we pulled over. On the physical side, we pulled in and kind of developed these models around hydrology and the power system, also the semiconductor manufacturing industry. Human well-being, we've got a whole bunch of kind of indicators that we started pulling together on both the human well-being and then also social mobilization fronts. Those are the kind of two active ones we're working on. And then we've also been working with civil affairs to start identifying what are their key actions and activities that they might engage in as a result of analysis from this. So I'll talk a little bit more about those three, just to give you a better sense as to what we're doing there. So one comment on the kind of climate prediction work. So X is temporal, Y is spatial in terms of kind of the scales of interest for civil affairs and kind of what data is available. So they certainly care about, they've kind of given us projections of saying they'd like to know what things are like 3 years out to a couple of years out. And as those folks who do climate modeling work know that there is a very significant gap in the 1 to 10 year range and that ability to do projections. We see NOAA kicking out, say, seasonal climate projections at a certain level that goes out to about 8 months. And then we know about the much longer kind of climate projection work that happens at the decadal and beyond scale. But there's a very serious gap in that kind of 1 to 10 year range. So we'll leverage those two in the red boxes or in the red ovals that you see up there. And then we actually have an effort underway working with Colorado State to try to figure out, is there a way we can try to backfill and get into that 1 to 10 year ranges? But that one's definitely a more kind of foundational research side of the house as well. On the physical infrastructure side, so just to give you a sense of kind of the type of work we're doing here. So this is more of kind of an abstract water availability model. We then are looking at this from particular water regions in Taiwan in this case. And then within this model, there are certain components we're identifying. So one are the kind of social networks at play here. So who are the organizations and the people in this place? And so civil affairs, again, they'll operate in these countries and then they will go and actually engage with organizations in that particular region to try to help, say, build that adaptive capacity. I'm going to avoid using the term resilience here in this talk. I'm learning here. But they'll actually engage with these foreign entities. They'll be working with organizations like Department of State, USAID and whatnot, or NGOs in those countries as well. So understanding this kind of social networks at play is very critical for them. So that's one key piece of the physical kind of infrastructure we're gathering and looking at. The next piece is obviously the physical infrastructure itself. So we've pulled in the hydrologic networks, we pulled in the reservoir information, we pulled in just kind of the pieces that are going to tie together into that physical infrastructure. And then the final bit is what we basically call kind of the utilization or the flux, if you will, through the system. So the production and consumption levels. As you can imagine, where you go around the world depends on what you're going to get in terms of this type of data. Luckily, where we're looking right now, there's actually pretty good data actually out there. We're doing this all purely open source. I would say that as well. There might be some access to some other data at another time, but we're trying to keep this all at the unclassed level because that's really where civil affairs operates. They want to be able to work with NGOs or work with State Department or aid in these capacities. And so these kind of three components, however, are really becoming kind of a core of when we think about physical infrastructure, what is the type of data that we're trying to gather to support the analysis we want to do here. On the social side, then we kind of take the outputs coming from that climate and hydro and power information, but also coupling that with both semiconductor. And there's a portion of this looking at agricultural production as well in Taiwan. There's kind of a question of kind of natural resource allocation as to whether they pipe water over to industrial manufacturing, agriculture. They've had significant drought in the past few years. From there, we kind of are looking at kind of vulnerability indexing coming off of that. We then look at that concept of that human well-being and what might be the impacts to that based on the vulnerabilities. Then we're kind of trying to pull in some of those social movement theories coming from that Minerva program that I mentioned. So what are what precipitate some type of a social mobilization? That takes us item 4. And then item 5 is what we're looking at is this notion of foreign influence. Again, how do we understand, say, foreign states that might be participating or meddling in the affairs of this region? So this gives us just a look at kind of some of the types of data we're looking at. So in kind of the well-being and social mobilization, it's things like economic data, medical data, things like that, like medical capacity of entities in this region. It's also looking at various demographic data as well. We're trying to capture this data at least at the country or the county level or higher resolutions, spatial resolutions as well. Again, your mileage may vary in terms of what's actually there. Then we kind of start thinking about what are the types of analysis we're going after, and there's certain kind of human well-being indicators we're trying to gather and actually do some aggregate indexing. On the social mobilization, we're looking at more kind of some of the public opinion surveys, some of the social media sentiment analysis as well. Those are kind of some of the techniques we're pursuing for how we're going to gather. And I would say this is really where we're actively working on right now. Just starting this quarter, we're doing quarterly releases on this project, and so we've really just started this activity this month, actually. So if we look at kind of the modeling and analysis we're doing so far, so in the kind of climate weather, we're definitely looking in the less than 1 year, and then the several decades out. In the physical and the bio side of the house, we're doing both on the hydrology and the power systems. And then in our case study 2 in the Philippines, there's a fish abundance model that we've been working on. Actually, I'm a former NOAA fisheries guide, so we have some of my old resources over there for some of the stock assessment work that they've done. And then in the social infrastructure, there's a few kind of components we're looking at. There's human well-being and mobilization, but also some just basic kind of social network analysis, especially in the field. And the near future is really tackling that kind of 1 to 10 year climate range that I mentioned. Looking at the food and agriculture in Taiwan, and then the industrial manufacturing. And then finally, for the near future on the social, we'll be looking at the foreign influence component as well. And then kind of longer term, there's a desire to actually look at more medical and the human migration problem as well. So there's kind of a question as to, again, we're trying to kind of build capabilities that we can actually hand over to some operational users. So the question is, well, how might they actually interact with this? They have a system called Maven out there. We will probably feed data into that and actually tie analytic services to that. We see there being a couple of classes of users, 2 or 3 classes of types of users here. We will provide them our kind of analytic notebooks that we've developed as well to do the prototyping around the analytics if they have more advanced users. And then we'll probably do some custom model interface development as well. I'd say the first 3 items are actively being worked. The 4th one is some initial work has been done there as well. We've been talking with the program at DARPA called World Modelers that's more in a transition phase now to try to leverage some of their capabilities for pulling in here as well. So if we tie it back to kind of civil affairs needs, so they care about that CivCop I mentioned, they care about understanding vulnerabilities, how those might feed up into larger instabilities in the region, and ultimately what are the actions that they want to take. They kind of talk about this in terms of the what, so what, and now what. What's happening? What's the environment on the ground? So what about it? What are those vulnerabilities, and what might be possible instabilities that arise? And then what are they going to do about it? But now what? So just looking at kind of our next quarterly goals, this quarter, we're kind of finish up really some of this modeling around hydro and power systems and semiconductors, really getting some of the initial model capabilities in place for the social side of the house as well, and then doing a coupling between these models as well. Philippines is looking at this fish abundance model and trying to get a forecasting capability on that, and also implementing that social network analysis I mentioned. And then we're doing a bunch of engagements. So we're trying to figure out how we can actually deploy this to their space via AWS, how we can do kind of bulk data pushes. We're really trying to figure out how do we do kind of analytics as a service. So as we have multiple analytics or models that we might want to introduce in here, how can we do that in an abstracted way so we can continually add more capabilities in that? That's where we think that Dr. World Modelers program might come into play, enable us to do that there. And then finally, there's an exercise coming up we're looking to participate in. Okay, so with all that, I thought I'd talk a little bit about how do you actually deploy stuff into DoD spaces. So our general philosophy in this program is we're trying to take the best in the kind of the climate and social science space, and we are trying to really meet the users where they are. And so that's kind of where Prepares Projects fits. We're trying to figure out how does civil affairs do their operations and their reporting today. So what are the tools and operational deployment kits that they use? When I think about deployment to DoD environments, I think there are kind of four key concepts to think of here. So one is, well, you got to identify and partner with your operational partners early in the process. Really understand what do they care about and kind of what are the capabilities they want to see in this. The second one is you really need to develop that, I think, operational case studies around what they care about as well. A lot of times we see projects kind of, even though they partner with studies, they'll still kind of do their own things and they won't dial into case studies that those particular users really care about. Another one is you really need to identify your deployment pathway early. So don't wait until you're in year 4 of your project before you got to think about how am I going to deploy this thing. We're already talking with potential deployment target pathways for our project, and we're in year 1. We think that's critically important. The final bit is get into that process where you can deploy quickly and iterate on it very rapidly. And so use things like continuous integration and deployment to do that. Just another thing I kind of like to talk about here is there's kind of what I'll call the foundational R&D or the basic R&D and kind of the operational or applied R&D. And I think it's really important to understand that they're just different, right? They're different in terms of their success criteria, what you're thinking about. SERDP is more kind of basic research, so it's more interested in publications, conferences, new algorithms. The operational side is more interested in like how can you deploy, kind of your delivery speed, getting new data streams flowing into the system. You have kind of different connectivity between them as well, right? It's like these are typically going to be kind of slower iterations over here. You're going to try to iterate faster over here. You want to be able to understand what are the challenges over here that you need to bring back and possibly engineering best practices. But over here, the idea is like, what are those 10x capabilities? Like, I think some of Dave's comment about, the surprise factor and whatnot could be some of those kind of 10x capabilities that we should be thinking about in this space. I think there's kind of a different notion of reproducibility potentially here as well. We are doing all of our code as infrastructure as code. Deploy it rapidly to different environments as necessary. I'm going to guess maybe some of your research code, maybe not quite at that level. Maybe, could be, but a lot of times there's kind of what we call research off the shelf, a little more ad hoc. Then there's kind of the TRL level. This is kind of just a fictitious diagram, but it kind of varies as to where you are on the TRL level as well. Typically when we're doing the operational R&D, we're in the higher levels. We need something that you can repeatedly to build and deploy and actually be used by the users out there. Okay, so then finally, just a couple more slides. What does success look like for us? If you think about as you're developing capability, right? One is you need functional code. You clearly need that. You need to pass your tests, your security tests, right? You need to deploy to the environment. We don't consider that success yet. You need to test and evaluate that code. Getting closer to success at that point. You've got sponsor adoption. You are finally in the success category at that point. If you get enterprise adoption, you're definitely in success. That's how we qualify success, when you're in those last two categories. Anything before that, I've seen large projects, for instance, that get all the way to here, spend millions and millions of dollars and never get to the sponsor adoption. Honestly, that's a failure in my opinion, especially if it was targeted for sponsor adoption. It's a failure. It didn't achieve any impact. I think that's it. And it is 1 minute to 4. To answer any questions, but I also know it's 4. So
Yeah, we've got plenty of time.
This was fascinating. So let's have questions. And by the way, after questions for this session, if there are 1 or 2 remaining questions from earlier session, please feel free to ask. We are at 4, but it's okay.
We have
There's an announcement that Robin is going to make, but that's fine. So I think we had Ayushi first and then Marta and please.
Thank you so much. That was very interesting. I'm a PhD student here in Professor Ganguly's lab. I'm interested in climate migration as part of my research. So when you're thinking of indicators for social mobilization, are you thinking mostly economic indicators or are you considering climate-induced ones as well?
absolutely climate-induced ones as well. And I think once you get to the social mobilization, a lot of what we're thinking is we will certainly have kind of human well-being indicators kind of bubble up to that. And then we're kind of probably going to be going down a kind of a causal narrative or kind of scenario exploration pathway when we get to the social mobilization, and then trying to work through kind of more, the notion of what are the plausible scenarios, and then kind of trying to quantify those with what are more.
All right, quick follow-up. Are you considering only internal migration or external as well? Like
Definitely external as well.
Awesome.
Todd is in Boston.
Awesome.
Just a note.
Thank you.
Yeah, and we're trying to, I will say this, we're working with Daniel Alder, trying to hear.
Oh, great.
Try to bring on him on his contract for some social capital work.
He has actually been working with Daniel as well. So great.
Maybe you could be our student.
There you go. Marta and then Dave.
Thank you. Wonderful presentation. I'm very interested in the social network modeling. Can you share what type of data or modeling you are using in that area?
I wish I could. We've got some folks at MIT who are helping us with that. I don't have a lot of details on it right now. I know they're doing a bunch of open source.
Also data too. It has data on
Yeah,
it.
there's definitely data. It's looking at more, now one's in particular focused heavily in the Philippines, and it's looking at like fishing cooperatives and who are the regulatory agencies and whatnot, and kind of the network and power dynamics between those entities. We're supposed to get, this quarter is going to be our first time to really get a kind of initial data set on that one. Happy to share that, I think, once we pull that together.
If you have MIT looking at that, definitely you need Northeastern and
Trying to bring the Boston thing.
Thank you. Really interesting and thoughtful talk. I'm curious on the deployment side, what you're seeing in terms of the end user and the expectation in terms of level of expertise. Because that can matter a lot, right? So if you've got people who are comfortable running Jupyter notebooks, that's a lot different than if you have to give them, drop downs and very simple. And this whole infrastructure space has gone through its own, right? And in the mid 2000s, right, DHS was asking for decision support tools that somebody who knew nothing with a day of training could make large, right? And it was like, exactly, right?
So maybe a couple comments to that. So yes, I mean, this is a hugely challenging question. We have definitely seen, as we think about this group of users, we've seen the sergeant who we're just going to give them maybe a couple of knobs to say, turn the dial high, medium, low type of knob. That's what they're going to get. We've also seen the master's, student who's a mathematician who can play with Jupyter notebooks as well in this core, if you're in the civil affairs core. So we've seen both. We are leaning right now to say we are simply going to give them a couple of knobs to turn that are very restricted. And then we on the PNL side and folks we're working with will really kind of control those models pretty tightly, right? I think that's where we're leaning right now, because otherwise it gets very dangerous. The other thing I'd say is there still is also a question as to, okay, great, you get Captain Schaefer, who's great, by the way, this guy, Captain Schaefer we're working with. He's going to go brief with the boss and say, boss, we run these models and look at the results are, we need to focus our resources in this region and this is what we should do. The boss is probably going to say, what confidence do I have in that? how do I know? That's some abstract model out there. So that's the other thing we're thinking about is how do you understand notions of kind of proper use around this? How do you understand notions as to conveying confidence in the results? What does that look like? That's why I think some of Leon's stuff earlier today, where he had some of those gradations, and I forget the terminology you had in there, but I was definitely want to look at that some more. So we're starting to think through that. I don't know where that goes yet, though. I mean, I'd love to get your all's kind of feedback as to what you've seen work, or maybe more importantly, where are the landmines as well in this space.
Yeah, I mean, I don't know that there's a simple answer here. And it depends on what Captain Schaefer does as the intermediary to ultimately make the presentation. But it's been our experience that you never want to brief one recommended course of action. You want to brief a top 5 courses of action.
Or whatnot.
Right? And that way the decision maker can say, oh, I like number 3 for some reason that I never articulated. Right.
I could see that. I could see, hey, sir, here are the I can imagine like here are the top 3 COAs or whatnot, and maybe here's the one we recommend. I can imagine that's a pretty typical military, delivery, if you will. I think it's a great question. It's not one I know where that's going to go. I've got some initial, I'd say we've got some initial ideas. Like I said, I think we'd be very interested in the community here as to where are the landmines in this space, right? Kind of goes to some of your comments about the cognitive science, kind of almost interpretation and, utilization of that discipline in this space as well. I think it's a challenging one. I mean, because these literally can be 4-person teams led by a captain and like a sergeant first class and, a couple other, privates and whatnot that are pretty junior out there. And while we've seen some really insightful captains and whatnot, that's on all of them. Right? Maybe at once who are just over there. So you really have to constrain it and think through what that's going to be. So yeah, I'm all ears for ideas there. We'll try things out. Like I said, we're going to iterate a lot and see what we can do. But I'm sure we're going to fail 5, 6, 7 times before we can, of course, get in.
I mean, I guess maybe one thing that would go with that is as you're trying to aggregate these things together, understanding where the sensitivities on those inputs are, right? So you might have like one model where small variations actually end up with big changes, and another model where
it doesn't matter. So
doesn't matter so much, right?
Yeah. There's so many things to think through on that front. And it's hard, right? I mean, we've got a stats team thinking through the whole uncertainty quantification and how we're going to propagate error. There was a talk through some kind of all throughout this stuff, but that's just hard. We've kind of identified how we think we want to do that. I don't think we'll get serious with that until probably next year. Just because we're trying to right now just get, can we wire this thing through kind of end to end right now and see what we have at that point? And then we need to start saying, okay, how are we really capturing error kind of in each step, and what is that? How does that really go? So yeah, like I said, I'm all ears for ideas that you all might.
Amy?
Really appreciated your philosophical summary at the end of the 6.1 versus 6.2. And I wonder if you have, from all your experience, any advice for what universities could do to help facilitate their faculty who want to work on that operational type research? Because if you look at that summary, all of the expected outputs of the more basic are what faculty are rewarded for by most universities. So if you
Changing incentive structure? Yeah, no, that's hard. That's probably not gonna happen anytime soon. Hubert and I were actually talking about this a little bit, right? It's like, I feel like, at least in this space, there's kind of like the SERDP ESTCP, which, SERDP's a little bit more basic. ESTCP is more kind of applied in that sense. We're trying to do something similar on the social science with Minerva as well here. How does the academy, so to speak, kind of get more engaged in the operational side? I mean, certainly you can partner with folks like the labs. I mean, we can have pathways to help get in there. And certainly just go after contracting vehicles as well, directly with the Defense Department and other agencies as well. I think that can be hard at times right now, but probably, working in communities like this and identifying which, it'd probably be useful in this type of community, which of the folks are more on the operational side and which are more on the, basic research side, and then doing a partnering there, right? I think as a community, we need to figure out how to enable that more. We don't do a good job of that, right? How much of the work from here ends up in papers and conferences, which is great, and we need that, but then how much doesn't go beyond that at all? That's where we need to I don't pretend to have those, what the right idea is, but I think if we can at least in these forums, have those dialogue, exchange business cards and see what we can do. The fact that we're trying to bring on Daniel from Northeastern, and my goal there is I want Daniel and I want social capital and social infrastructure from him, but I want it as a venue to get to Barabasi's people or to get to Usama's people or something like that, anyone at Northeastern basically where I could say, hey, why don't we get some people from over there as well? It's just more a vehicle by which I could get to Northeastern students. I don't know how I'm viewing it right now.
And also to sort of add on to that, I mean, there are some things we do, right? I mean, we are working with PNNL and, of course, various parts of the, Army, Navy, Air Force right here. So that's great. But just to give an example, Todd mentioned going from SERDP to ESTCP. SERDP is what we think as faculty. I mean, realizing also I've been at Oak Ridge Lab before, I've been in the private sector before, so my background has not been linear in terms of academia, but still, right, once I enter, I start to think, oh, SERDP. The moment it gets to ESTCP, oh, the Oak Ridge National Lab is leading it. That there is something that needs to change there because I think there are things we can do in collaboration, right? So that's one thing. Similarly, that's here. That's a project which, you guys leading as a PhD student and August was here. I mean, he's sort of co-leading. So again, we are at the stage already in category 1. Category 1 is supposed to be just show that it has a flavor of maybe it'll work. We're already at a stage where we are working with the Tennessee Valley Authority and they're saying, give us your codes, give us the thing, we'll want to run it. And you had that statement there, which is, I think, just before your success, that it is being used there. But that extra step is not easy, right? So then we have to go and sit down with them, work with them, and to some extent they are doing that. But that's also where I think the university can help building that, in this case, connection with NASA, TVA, and a lab like PNNL or RNL. So I think there's a lot to discuss and we'd love to talk with you, right? I mean, this conversation, I think will be, I mean, I would hope will happen more.
Add something just because I sit on the SERDP ESTCP committees. I would disagree. There's a lot of ESTCP projects. They're typically 2 years. They're targeted towards master students, which result in very high impact journal publications. And we are shifting more and more towards that. So the R&D is not dumb R&D, right? It's got a different focus than the fundamental 6s, 5s, right? All of those. But they do result in really high impact publications.
I have never had an ESTCP, so that's very good to know then. One person actually I know who just got an ESTCP from academia is Sai Ravella. I don't know if you know the name. He's at MIT. We have been collaborating for a while. That's good to know. So we should talk to them more. So absolutely. Anybody else? Any other question? If not, I wanted to end with maybe this session. Oh, that's August. I was just talking about him. So I wanted to end with one question. So we have been talking about complexity for a while. This is for all of us, and we can talk here later. Complexity, complex systems, and all that. My mind still works in a simple way. So I try to put something in simple way and try to see if I can understand and then go somewhere. Here's the problem that I sometimes face. So let's take risk. Let's take so these things that you showed, I really like, from climate side to infrastructure, social, and then action, etc. Let's take the first box there, climate side, right? So you talked about working with statisticians, and I think that's very important, but also some of us here are, a few of us here are at nonlinear dynamics, and I'm using the royal we, some of us here. So, and the interesting thing there that we are finding, typically what you'd expect. So there is something, there is a standard uncertainty, like, so y equals a plus bx, there is uncertainty in a and b estimates, and hence there is uncertainty in y, fine. Then there is uncertainty that's called the deep uncertainty, where you cannot assign likelihoods. If you can assign likelihoods, right? I have probability, I sort of multiply that with consequence. I can do risk-based design as a simple-minded engineer. That's what we typically do. Okay, now you give me, what what some people call deep uncertainty. I interpret that as scenario based, like SSPs, right? Concentration pathways, carbon dioxide pathways. So, okay, what if scenarios also we can deal with flexible planning, etc. There is yet another kind of uncertainty that we sort of knew about, but that's emerging even more, especially in climate. In weather, we know that, but climate we didn't expect as much, is what is being called irreducible uncertainty. This is something where we are seeing, we thought that, internal variability, as it's sometimes called, right? Initial condition. In climate, we thought those transients would go down. So this internal intrinsic variability of the system, we thought, okay, if it's indicating, if one of them is indicating heat waves, or one of them is indicating floods, or one of them is indicating this particular insect will die, whatever it is, other such internal variability indicate the same thing, maybe a little bit more or less by magnitude. What we are finding is in some cases that's true, but in many cases, indicating floods versus droughts, insect living versus insect dying. And we don't know yet, collectively I'm saying, the Royal, we don't know yet how to assign how to assign likelihoods with that, how to use that for design, even what to do in terms of what if scenarios. Is that surprise? Is that the possibility of surprise that we cannot quantify? How do I use that and do my engineering design? And what does that mean for this end-to-end flow of systems? So I'll just leave that as an open thought while we have some beverage.
Maybe over beverages. There's many ways to deal with it.
That's what I said. So Robin has an important comment to make.
Okay, so